Welcome. Welcome.
Welcome.
Welcome.
Welcome to Azure Cosmos DB Conf 2023.
Welcome to Azure Cosmos DB Conf 2023.
Welcome to Azure Cosmos DB Conf.
Welcome.
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 Welcome to the Azure Cosmos DB Conference 2023.
Welcome to Azure Cosmos DB Conf 2023. This is the third time we're doing it, and it's so amazing to be here live in the studio. My name is Deborah Chen, and I'm a product manager on Azure Cosmos DB. And I'm so excited today to be hosting with my co-host, Tara.
Thanks, Deborah. I'm Tara Bhatia, and I'm also a PM on Azure Cosmos DB. This is actually my first time hosting live in Redmond, and I'm so excited to be a part of this. So thank you for joining Deborah and I in this 3-hour show all about Azure Cosmos DB, along with almost 20 on-demand talks that you'll be able to find on our YouTube channel. If you miss any of the sessions live here, you can always find them on demand on aka.ms/Azure Cosmos DB Conf on demand.
Yeah, it's really, I can't believe we're in our third year. I remember the first year, I think we were hosting all at home, so it's so nice to be here live and in person. So we host this conference every year so that you can hear from the people building the product, see what's new, best practices. It's also a great time to celebrate our community, our customers, and really hear their feedback, your feedback on how you're using Azure Cosmos DB to build all of your real-world solutions.
Yeah, and we definitely want to hear from you during the show. Our community is so important, and if you have any questions, comments, or shout-outs, feel free to leave a comment in our YouTube chat or send us a tweet with #AzureCosmosDBConf.
Yeah, so much content to show you today. Tara, what are you looking forward to the most today?
Yeah, I'm really looking forward to listening in from our customers and actually learning about what use cases they're using Azure DB for. And I'm super excited to also learn from our own team members about their tips and tricks on how to actually best use the service themselves.
Definitely. One great thing about this is that, over the years, we hear so much feedback from so many people in so many channels, from one-on-one customer meetings to tweets, comments on YouTube, to presentations, to just, hey, what's going on with the product? I'm having this problem. So one thing that our team has done is really distilled all of that into best practices that anyone can follow today, super actionable. There's also a bunch of customers today. Again, it's so gratifying to see, there's so many engineers and PMs and so many people who make this product work. And just being able to see it actually working in real life and having impact is so awesome.
Yeah, definitely. Like Deborah said, feel free to say anything about the product that you have here in the YouTube chat or on Twitter. We're definitely looking at it, and we're definitely using it for new features and trying to incorporate that customer feedback all the time. So this is your chance to let us know what you like about our product, what you don't like about our product, and we're here to listen as well.
Yeah, let us know your feedback. Let us know your thoughts. Again, the hashtag is Azure Cosmos DB Conf. We really want to hear from you. If you're watching this live, take a picture yourself, send it on Twitter. We'll give you a shout out during the show.
Yeah, how about we start that interaction right now? Let us know where you're watching this from. We're here in Redmond on the West Coast pretty early right now. So East Coasters, you're definitely had your cup of coffee. Let us know where the rest of you guys are watching this from, and we'd love to learn about that as well.
Sounds good. One more thing I would just say is, as a product manager working on this product, you hear day to day, you're so deep in the weeds of, how am I going to solve this problem, this problem, this problem. But the great thing about today is it's really a celebration of the best of the product, the best of our customers, use cases, and studies. There's so many exciting customer stories. I can't wait for everyone here to hear about. We've heard a sneak peek ourselves, and I think you'll be pretty amazed at the scale and the really what Cosmos DB can deliver.
Yeah, definitely. I think Azure Cosmos DB, it's on pretty much anything. If you're ordering coffee online, they're probably powered by Cosmos DB. So let's settle in and let's get the show started. Yeah. What do you say, Deborah?
Sounds good. Let's get the show started. First, we're going to hear from Kirill Gavriluik, General Manager of Azure Cosmos DB and Postgres at Microsoft, to kick things off with our keynote. He's got a ton of exciting content and some exciting announcements to share. Let's join and welcome Kirill.
Hello, everyone. I'm Kirill Gavriluk, General Manager for Azure Cosmos DB and Postgres. And today I am excited to welcome you to our annual Azure Cosmos DB Conf 2023. Woohoo! Cosmos DB is all about developers, right? That's why it exists. And developers write apps, and the apps have changed. When you and I went to school, many of us have been building apps like what we see on the left side, which is we write the UI, the user tells something to UI, the UI puts some data into database. The user tells app what to do. The new apps, the apps that the customers want to build today, the app tells the user what to do. The data is gushing into the database. Then the database triggers all kinds of processes, all kinds of microservices within the app. And those microservices are driving the experience to provide contextual, real-time experience to the customer, predicting what they want and telling them what they really want. The app is no longer an augmentation to the business. The app is the business. So it's by definition mission critical. So what do these apps want, right? These apps are all data-driven. They're not UI-driven. They're all about massive data volumes at high velocity, frequently changing data. The apps is the business, so the apps are by definition mission critical. They cannot go down. They cannot even experience a blip during cloud upgrade or anything. And this use case where it's data-driven, the data triggers the experience. It is not limited anymore to just IoT, or it is everywhere, in every vertical, every use case. That's what we see today. It's the same application pattern. So what database do these apps need? Azure Cosmos DB is one such database. It is designed, built from the ground up in the cloud for these type of apps. It is serverless by design. There is no server out there. It physically does not exist. It provides you guaranteed speed and performance at any scale, thanks to this horizontal scale out, horizontal elasticity, limitless elasticity, and is able to achieve the best TCO while doing so. It originated as a NoSQL database, but recently we added relational because this pattern of high scale, high volume is no longer limited to NoSQL. Relational world wants the same. The scenarios that want rich queries, distributed transactions, they still want scale. No one can live anymore within the constraints of a single virtual machine. Cosmos DB offers open source APIs. We believe in open source. We provide you open source Postgres, and it is true Postgres. It's actually a Postgres engine running. It is not an emulation of some sort. Cosmos DB offers MongoDB API, Cassandra API. We offer a very flexible, schemaless NoSQL stack. We also offer Postgres, where you don't have to scale out necessarily. You can use it as a Postgres database, and it's just Postgres, 100% with all the extensions that you want, or you can scale out and benefit from this limitless distribution and distributed query. Cosmos DB is known for reliability, for these 5 nines SLAs that it gives. Thanks to the global distribution, we can move your data anywhere where your customers are. We can also make, by globally replicating your data, we provide you these 5 nines availability and very fast failover. Finally, Cosmos DB provides you real-time analytics thanks to integration with Synapse Link. Whether you want Spark or SQL interface, you can get real-time analytical insights into your data as it's coming into the database in real time. Now, what do customers do with Cosmos DB? It turns out any of you probably do not live a day without interacting with Cosmos DB. We wake up, we order coffee from Starbucks, goes through the Cosmos DB. We join a meeting using our favorite remote meeting software, whether it's Teams or the other very popular meeting software, all use Cosmos DB. We go order groceries for lunch, likely uses Cosmos DB. We go and order, we're running short on our clothes. we go to Walmart.com or your favorite e-commerce retailer, likely uses Cosmos DB. Finally, we relax at the end of the day to our favorite music from our favorite music streaming service. Many of them use Cosmos DB. In your any day, given day, you're probably spending at least 4 to 5 hours interacting with Cosmos DB. Now, in terms of the patterns, application patterns, we pull this from our product telemetry. This is actually literally a query from our telemetry with some creative machine models that does that did some inference based on the shape, based on the names of the table, databases, shapes, etc., shapes of the data. We get this list of these as the top 25 use cases. As you can see, a lot of it is about real time. A lot of it is about this cloud native application pattern that deals with events, like the event store pattern. A lot of it is about AI with bot and chats that are built. Many of them are built with Cosmos DB, with a real-time user data and insights and segmentation on it. Retail, IoT, banking, the verticals are pretty much any vertical has these patterns, has these scenarios, and is using Cosmos DB. Cosmos DB is known for scale, right? That's how it was designed. So if you're interacting with Teams, for example, all of the messages, everything you ever did with Teams or the user profile, that all stored in Cosmos DB. It's trillions of transactions per day, petabytes of data, ever growing. Second biggest world e-commerce website, Walmart.com. All transactions there, all are in Cosmos DB. There is a very nice blog by Walmart explaining how they build it. Healthcare, very cool. Customers creating petabyte plus size databases, and the Cosmos DB team doesn't even know about it anymore. They just get created. It is known for its scale. ChatGPT is a great example. Like OpenAI was probably the fastest known startup to grow to 100 million monthly active users, right? And they're using Cosmos DB for messages and inputs, like it's very well known fact. They're running on Azure. Cosmos DB did not even have a blip from this, right? It's known for its scale. It's really good at fast, instant scale as your business grows. Now with that, let me introduce a customer and hear from them how Music Tribe is helping musicians around the world with Cosmos DB.
Hi, my name is Tiago. I'm the head of cloud and platforms at Music Tribe. Music Tribe is a global company made up of 12 different brands. Music Tribe empowers creators in different scenarios, such as live sound, home and professional studio recording, gaming, podcasts, and online streaming. And we are now doing that on Microsoft Azure. The migration went according to plan. The preparation took us a bit longer because of our lack of experience with Microsoft Azure. But with Microsoft support, we got the guidance we needed to migrate with no impact to our customers. Music Tribe made a strategic bet on Microsoft's tech stack. So the move to Microsoft Azure was natural to us, but we needed to make sure this is the right choice for our short-term and long-term goals. In the short term, this would mean that we would migrate to Azure and continue to offer the same level of service to our customers. In the long term, this would mean that we'll be able to reach a much larger customer base distributed globally and leveraging the scalable architecture defined by Microsoft in partnership with us. With Cosmos DB, we could increase the presence globally and improve the service we offer to our customers by leveraging Cosmos DB multi-region rights. Also, we now run multiple environments that scale on demand, allowing us to optimize costs of our data infrastructure. And last, the team is now exploring new ways of building asynchronous capabilities using Cosmos DB Change Feed to offer easier integrations with other platforms.
Well, thank you, Music Tribe. Now, what's new in Cosmos DB? Let's talk about, a year has passed since we last talked to you at this conference. A lot of improvements in Cosmos DB scale, elasticity, and high availability. Specifically for Cosmos DB scale, we released in general availability burstable capacity. So you no longer have to provision to the max of your RU consumption at every given partition. If any partition decides to burst, you get it for free. You don't have to provision for bursts. We offer you partition merge. So if you're ingesting a lot of data up front at the beginning, for example, and then want to kind of shrink to get to the footprint in Cosmos DB that your steady state, partition merge is a great way to do that. We're offering a larger serverless collections. Serverless has been super popular. Actually, like autoscale and serverless now account for roughly 70% of our overall usage of the database. And they're just all serverless. They're just for different type of scenarios. And now the serverless where you pay per request, those collections are now can grow up to 1 terabytes. And after that, you can transition to autoscale, which is a serverless but is optimized for higher volume and higher transaction volume. Another cool thing that is coming out and we're announcing today is MongoDB API gets a facelift with vCore capacity mode. Now let me step back. MongoDB API has been a very popular flavor of Cosmos DB. The reason is MongoDB is very popular, and Cosmos DB stack is providing very differentiated, strong capabilities around scale, this instant scale, transparent horizontal, and transparent partition management. So that fuels the growth of MongoDB API. Now, for many MongoDB scenarios, developers are used to large shards. They're used to a notion of core CPU, 1 CPU, 2 CPUs. So the Cosmos DB native concept of request units has been, let's say, not very familiar to them. vCore capacity mode solves this. You will get familiar settings. How many vCores do you want per shard? You can scale out, just like with Cosmos DB RU, so you can scale out and add as many physical shards as you want. But you're paying for it in vCores. You provision, you plan your capacity in terms of vCores. Your shards can be large, any size of the VM that we have in stock. So it's very familiar to MongoDB developers and still retains that value of Cosmos DB of this transparent shard management. It provides much higher compatibility. And it's a very fast solution. It's great for lifting and shifting your MongoDB applications, right? Great for writing new applications, provides you high performance, low TCO, and it's very fast at rich queries. So new capacity mode in MongoDB API, and simultaneously with that, we're releasing support for version 6.0 of MongoDB. We're offering you 2 architectures, 2 capacity modes, request units, vCore. Request units are great at this instant and limitless elasticity, right? That's kind of a Cosmos DB native value add. vCore capacity mode is great at higher compatibility, higher shard size, more familiar, better at your cost planning. You're paying for instances, you're paying for disks. So look a lot more familiar than request units to MongoDB developers. Developers. Cosmos DB is all about developers, right? And we cannot get tired, but to provide more and more and better support for our developers. We're providing a good, broad investments around better drivers, in a lot of investments in Java driver, in .NET, in Node, in Go. Atypical to Microsoft, actually, a lot of features show up first in Java driver for Cosmos DB. We're investing a lot in the ecosystem with Spark, improvements to Spark, support for 3.3, Azure Active Directory support, Kafka connector got improvements, support for Merge is now part of all these SDKs, support for multi-tenant applications, which is footprint of multi-tenant applications in Cosmos DB is growing every day. We're providing capabilities in the SDK around hierarchical partition keys, faster, richer queries. These are both on backend side and SDK side. So better drivers, better integration. Security. Cosmos DB is enterprise-grade software. Lots of mission-critical, highly secure, sensitive data is running on Cosmos DB. We're providing you customer-managed keys now for existing accounts, for multi-tenant applications running on Cosmos DB, where you can provision a different key per tenant, HSM support, network security perimeter in preview. It is enterprise grade and secure by default. Now, last fall, we also announced a new member of the family of Cosmos DB, Postgres. We added a relational API to Cosmos DB. And it was different from our original approach to the APIs. This is actual 100% Postgres. That is not an emulation. It is Postgres that comes with some 50 plus Postgres extensions. It is fully 100% compatible. It's just Postgres for uncharted data. And because it's part of Cosmos DB, it also supports scale out. And of course, once you scale out your table, then some of those capabilities of Postgres may not make a lot of sense, like global index for high scale out, maybe not the best design pattern, but you get ACID transactions, you get support for primary foreign keys, all of that is maintained as you scale out. Rich data types, rich queries. We offer you local and global replication alongside with it. And it's important, is just like the NoSQL Cosmos DB offering, it provides you online scaling. So application does not notice when we are scaling out your Cosmos DB Postgres database. We provide you fairly sophisticated support for multi-tenant applications. You can isolate tenants to a dedicated capacity within your Cosmos DB Postgres database. You can easily move tenants, accommodate for spikes, hot tenants. There is a fairly extensive tenant management with distributed Postgres in Cosmos DB. Now, this winter, we announced additional improvements to Cosmos DB for Postgres, online scale out, hot tenant rebalancing, burstable capacity, significantly lowering the entry price. So now you can come in and for $10, you can get Cosmos DB for Postgres. There is also a free tier, no commitment, no sign up for Azure is required. Just try Cosmos DB. You can search it using your favorite search engine and click on Try Cosmos DB and choose Postgres API. It's free of charge, infinite renewals, and you get full power of Cosmos DB for Postgres. You don't even need to sign up for Azure. And finally, we're starting to add more and more enterprise-grade capabilities to this stack. So we're adding Cosmos Customer Managed Keys. We're going to add Azure Active Directory very shortly, as this is very common in the enterprise scenarios. Now, to our second guest. This is actually very close to Microsoft, our own LinkedIn. LinkedIn is one of the top websites in the world. It requires superior reliability, top performance to provide the user experience LinkedIn users are accustomed to. It's one of the world top apps. And let's hear from LinkedIn how they achieve performance and reliability with Cosmos DB for their user interface.
Hi, I'm Ankit Gupta. I'm Principal Software Engineer at LinkedIn, and I am the tech lead for the team which builds Enterprise Platform as a Service offering. So my team builds a Platform as a Service offering for enterprise customers that provides exploratory access to economic graph data of LinkedIn. And Cosmos DB is the key part in this technical stack. And the NoSQL solution from Cosmos DB is primarily used for key value lookups. This Platform as a Service offering provides an exploratory economic graph API, which is used by a variety of products, such as Outlook People Card, in which you can find details of LinkedIn profile for your contacts in Outlook. So fully managed offering, single-digit response times, high availability, and ability to scale to any workload, be it in the query workload size or the data size. These are some of the many features that attracted us to use Cosmos DB and why we have been using it for the last 5 years. But beyond the functional features, a true testament to any stateful system is how quickly the system and the team can react to operational issues. And Cosmos DB team, time and again, have demonstrated that they can respond very quickly to operational issues, have the due diligence to find the root causes and fix those issues in a timely manner. And that has been the case multiple number of times in the last 5 years.
You're going to learn a ton at Cosmos DB Conference 2023. We're going to talk about best practices, new features, lots of new exciting announcements in Cosmos DB. We're going to talk about apps and scenarios that Cosmos DB enables. Cosmos DB is the database for apps, for developers. We're here for you. Thank you.
Thanks, Carol. There's so many cool things that are going on right now with Azure Cosmos DB. I'm so excited to get into all the nitty-gritty of it and excited to actually try it out at home. Cool. So what did you like from that session, Deborah?
Yeah, I think biggest takeaway is, again, can't stress enough the customers. I mean, how cool is it hearing that OpenAPI and ChatGPT is hosting on Cosmos DB? Service didn't miss a beat. It was also really cool to hear from our customers, Music Tribe, as well as LinkedIn. I think these are who are powering the solutions on Cosmos DB, and just hearing how they're really able to run their business with Cosmos DB as the backbone.
Yeah, so we actually do have some shout outs from people from around the world. So let's give a big warm welcome to Peter from Denmark. We have Saul from Colombia. We have Pamela from the Bahamas. And special shout out to Cecil. The studio misses you so much. Hello from Florida. And I think we have some tweets too. Deborah, do you want to get into those?
Yeah, we've got VJ, Budding Geek, watching Cosmos DB Conf. I've got Andres as well from Colombia. Thank you so much for your tweets and for watching. It's so awesome to see the community interaction here.
Yeah, and keep it coming. We want to hear about your favorite features on Cosmos DB and other things that you've enjoyed throughout the show as well. And if you've missed any of the previous sessions, you can always check it out on aka.ms/Azure Cosmos DB Confs.
/collections, I think.
/collections.
You'll find it. All right, so let's go ahead and move on to our next two talks. First up, we have product manager from Azure Cosmos DB, Gal Levy, who will share more details about that exciting Mongo vCore offering.
Yeah, super excited for that. After that, we'll hear from Justine Kochi, who is also a PM at Azure Cosmos DB, and she's going to help us avoid some common issues people may run into when writing queries using the NoSQL API.
Hey everyone, welcome to Azure Cosmos DB Conf. I'm Gal, and today I'm presenting flexible, integrated, and cost-effective Azure Cosmos DB for MongoDB vCore, a brand new offering. So first off, my name is Gal Levy, and I'm a product lead here on Azure Cosmos DB, and I'm based in New York City. It's nice to meet you all. Today, we'll be talking about Azure Cosmos DB for MongoDB. So first, let's start with a quick overview of what Azure Cosmos DB for MongoDB is. As a developer, I want to get all of the benefits of Azure Cosmos DB, but I might already have skills using MongoDB, or I might already have apps that use MongoDB, and I don't want to have to change them. That's where Azure Cosmos DB for MongoDB comes in. Azure Cosmos DB for MongoDB allows you to use Cosmos DB as if it were a MongoDB database. This allows me to leverage my skills and my apps the same way they were before and get all the benefits of Azure Cosmos DB. So for example, Cosmos DB for MongoDB is compatible with MongoDB's apps, tooling, drivers, and SDKs. So it works just the way you expect it. The second thing here is choose your architecture. This is the brand new part. We first have request units, which you might already be familiar with, but now we also have vCores. Lastly is the native Azure integrations. This is a big one because as a developer, I don't want to have to build or maintain integrations with my other Azure services. I want them to be taken care of automatically. Azure Cosmos DB is a native Azure service, so this does this automatically for me. You can go to that link down there to check out all of our integrations. Let's talk a bit more about the two architectures. The first one is request units. This is the one you might already be familiar with. This is where you pay for throughputs as well as consume storage. The new architecture we're announcing is vCore, the brand new architecture. This is where you pay for instances and disks. This might sound familiar because you're accustomed to this doing so on-prem or in IaaS or in other MongoDB services. This is just the same way. You pay for instances and disks, and high availability is optional if you'd like it. Let's dive a bit deeper into Cosmos DB for MongoDB vCore. As I mentioned, this is a native Azure service that's integrated with the Azure platform, meaning the resource management, the efficiencies of using native Azure tooling are all deeply integrated, and you benefit from all of them as a developer. You enjoy the peace of mind of not having to support or build these integrations, as everything is backed by one single support team. Second is flexibility for you as a developer. With the vCore offering, you can scale vertically as well as horizontally very well, meaning that you need no shard key initially. You can scale vertically by a lot until your database surpasses terabytes, which covers many, many use cases. Second is pricing is based on very familiar concepts, such as vCPUs and disks. So it's very easy to compare and understand when you're coming over to our service, how to use it and how to price it correctly. There are also other benefits, such as no limits on collections and many other benefits. But ultimately, this is a familiar architecture that really makes sense for developers, and it's very easy to get accustomed to. Lastly, this is a fast solution that just works really, really well. Fast from the perspective of incredible performance by being based on Azure Cosmos DB, and fast from how easy it is for you to leverage the benefits with your MongoDB skills or your MongoDB apps. It's very easy to migrate over or develop new apps here. Lastly, this is a fast solution that simply works from two perspectives. One is how fast it is to develop new apps or migrate existing apps due to the fact that you can leverage your skills that you already have or the apps that are already written in a certain way. Second is fast from a performance standpoint. This architecture is based on Azure Cosmos DB, and it's very, very fast. In addition to that, the TCO here is great because we take all the extra performance and we pass those savings directly on to you as a user. And that's it. The solution is fast and performant. It's integrated and it's flexible for developers. Let's talk about which architecture is right for you. If you're looking into running long-running aggregation queries or complex queries, vCore might be a better option compared to running short queries that require consistent performance throughout. As I mentioned before, with vCore, you're getting dedicated instances that run in a way you're accustomed to, compared to request units where you have a cloud-native multi-tenant service with instantaneous scalability. Lastly, in terms of scaling with vCores, as I mentioned earlier, you can scale up horizontally as well as vertically by a lot. With request units, you're mostly scaling horizontally by sharding, which is done automatically for you by Cosmos DB. Lastly, in terms of pricing and how you're spending, in the vCore offering, you have a consistent flat fee based on compute and based on storage. In request units, the fee is variable and it all depends on your usage and capacity model. But in general, the way it's structured is based on throughput and it's based on consumed storage. Now, I want to take a moment here and highlight a customer of ours. I want to highlight a customer of ours called Software AG. They chose to use Cosmos DB for MongoDB vCore because of its integration, high performance, and total cost of ownership. And we really thank them for having us, or for having them as a customer, and we're really excited to work with them. Now, diving a bit deeper into the total cost of ownership. Here at Microsoft, we really want you to do more with less, and that comes with giving very, very competitive pricing to ensure you can do that. That includes what you might see over there. We have a non-HA option, meaning high availability option. So you can create clusters without high availability for dev and test, for example, and those are automatically 50% off. As I mentioned, we pass all the savings directly onto you. And you can see with the different types of cluster tiers, we have many choices for you to choose from. As mentioned down below, we'll continue adding additional cluster tiers, and there's much more coming soon in terms of pricing and TCO and ways you can do more with less. So we'd love for you to get started with Azure Cosmos DB for MongoDB vCore. Please check out aka.ms/try-MongoVCore to get started. And now let's go through a demo. So here in the familiar Microsoft Azure portal, you can choose create a new Azure Cosmos DB resource. You go over here and you choose Azure Cosmos DB for MongoDB, just as it was before. But what's different now is you have a choice between resources. You can choose the familiar request units database account that we always had. And now in addition, we have a vCore cluster, which is in preview now. And you just click create. You select your subscription, you select your resource group. Let's choose the resource group. I'm going to select my cluster name, select my region, and I'm going to click configure. In the configuration page, I can select how many nodes I want to use. Typically, we'll start with 1 here. I can select my cluster tier from the list. I can select my storage per node. And on the right, I can see the pricing come up for the entire month, estimated cost for the month. You're paying per hour here, but you can see the cost for the entire month if you were to keep it running for the entire month. And then I can select if I want high availability. Since I'm not running in production, I'm going to leave that off and click I understand and click save. Next, I'll put my username and I'll put in a password. So next we go to review and create. You can see all the details about what I'm creating here. I'm going to click create. And that's it. The deployment will start, and in a few minutes, I'll have a brand new Cosmos DB for MongoDB vCore cluster. But to save time, let's skip to one that's already created. Here's a cluster I created earlier with all the details of what's running. As I mentioned before, this is an M40 tier with 4 vCores and 16 gigabytes of RAM. The disk size is shown here. But in addition, I can always go to scale. And if my needs ever change, I can change the cluster tier up or down. I can change the storage per node. Any cost differences will be reflected here. And I can enable or disable high availability. And by clicking save with any difference, what happens is the cluster is changed live with no downtime. All these changes are done without any downtime, and the configuration is updated. So this is very convenient for scaling up or down and really scaling to fit your workload and your workload needs. In the networking tab, you can configure firewall rules, as well as go to many other tabs you're familiar with to change the configuration or use features or integrations with your cluster. But let's connect to the cluster and use it a bit. So let's go to connection string. I'm going to copy this connection string. The important part to keep in mind is you have a user and password that you configured when you created the cluster. In order to connect to the cluster using this connection string, you need to replace the user and the password with what you used, with what you put, and then you can actually connect. So I'll copy this, and then I just want to make a point here. If you ever forget your password, you can always click reset password here in order to change it. Now let's go to Mongo shell here. I'm going to connect with a connection string. Now you can see we're connected to Mongo shell. I already have a database here pre-populated with some data. So let's do show DBs, and we want to use the demo database. Now that we're on the demo database, I'm going to run some aggregation queries to show you what's going on. But first, let's do a find. As you can see, we have a list of orders with a customer name, a status of the order, and the amount, the total amount of the order cost. We're going to run some aggregation pipeline queries here and show how this works just as if it were a MongoDB database, but we're actually using Azure Cosmos DB for MongoDB in this case. So what this one did is this sums up each customer's fulfilled order amount and sorts it. So you can see we have the total order amount by customer. We have an order count that was also summed up, and it's sorted by the highest order amount. Here is another example. This will count the fulfilled and unfulfilled orders per customer. And you can see each customer has filled orders and unfulfilled, and the counts for each of them. And lastly, this one will calculate the percentages of fulfilled versus unfulfilled orders for customers. So as you can see, Azure Cosmos DB for MongoDB vCore works just like a MongoDB database, but it's backed by Azure Cosmos DB, and it's running Azure Cosmos DB for MongoDB vCore. So very, very easy just to get started with the tools you're already familiar with, and basically take this connection string and use them with your applications and with your favorite tools. That just makes sense for you as a developer, since you already have that background in developing with MongoDB. Thank you so much for listening to this talk. We're so excited for you to try out Azure Cosmos DB for MongoDB vCore and let us know what you think. Go to aka.ms/trymongovcore to get started. Thank you so much again, and enjoy the conference.
Hi, everyone. Welcome to Azure Cosmos DB Conf. I'm Justine Kochi, and I'm a PM on the Cosmos DB team. I focus on programmability, and today we're going to be talking about avoiding common pitfalls when writing queries with the API for NoSQL. So first, we should decide, when are queries actually useful? I have a sample query here, which is selecting all properties of my document from my container, where the ID equals my ID, and the partition key equals my PK. So for this specific query, where I'm getting one document by its ID and partition key value, there's actually a more efficient way to achieve this, and that is through a point read. You can execute point reads through any of the SDKs, and this is an example of what it looks like in the .NET SDK. I'm using read item async to query my document by the ID and the partition key. A point read only uses 1 RU for a 1 kilobyte document, and it is guaranteed to have sub-single-digit millisecond latency. This is really great if you want to get, one document by its ID and partition key, but of course there are many scenarios when we want to retrieve multiple documents, or we want other filters other than just ID and PK. So for these scenarios, we definitely do need to use queries. When thinking about optimizing a query, you might think, oh, should I rewrite the query, or where should I actually start? One really important place to look is your indexing policy. So Azure Cosmos DB is a database designed for developers. And because of this, we have provided a default indexing policy that actually works really great for most scenarios. So all document properties are indexed by default with a range index. This is really great for queries that have quality filters, range filters, most system functions, and also if you're ordering by one property. But there are many queries that are more complex than this. Maybe there's some combination of these, and you can optimize further than just beyond the default indexing policy. For this, we can use composite indexes. Composite indexes really increase efficiency when you're performing operations on multiple fields in a single query. This is really helpful if you have complex filter expressions. So maybe you have an equality filter and also a range filter, or if you have an aggregation with some filters, if you have multiple group by properties, so you're grouping by two things, or if you have multiple order by properties. Order by needs to be served from an index. So if you want to order by multiple things, you actually are required to add a composite index. Otherwise, your query won't run. But even if you just have one order by property and you add a filter or some other operation, a composite index can really help you get better performance. Okay, so what does a composite look like, and how do we know when we need one? So let's take this sample query where we're getting the category and the price from our container, where the category equals garden and the price is greater than 10. So we have two filters here. We have an equality filter and a range filter. A sample composite index that might help optimize this query looks something like this. It's important to remember with composite indexes, it's essentially a set of property paths where the sequence and the order matters. So here, our sequence, we have category first, and then we have price. And the order I have selected as descending for both. Since there's no order by, I could have either ascending or descending here, and the composite index would still work. But it is important to remember the sequence. So if you have a range filter, your range, the property that the range is on, needs to appear last in your composite index. Each composite index can actually only optimize one range filter. So what if we have a really similar query, but this time we want price greater than 10, and we want the date to be above March 1st, 2023. So in this sample query, we actually have two range filters, but not to worry, we can use two composite indexes to serve this query. So queries can use as many composite indexes or a combination of single and composite indexes as possible to really make the most of whatever indexing policy you have defined. Here we have two composite indexes. We have our category price composite index, and we also have category date. And again, this is because each of these composite indexes can only optimize one range filter at a time. So let's take a look at a couple other examples of this, and we'll look at a demo. So now I'm in the Azure portal, and I just want to show you what this container looks like. So I have one database and two containers. I have my products container and a products composite container. The data in both of these containers is exactly the same. I have a really simple product document with a name, a price, category, description, first available date, and an array of customer ratings. Each customer rating has both a username and a number of stars that the user has rated this product. My products composite container has the exact same data, but if we take a look at its indexing policy, instead of using the default indexing policy, you can see that I've added a bunch of composite indexes here. And again, the composite indexes are defined exactly how we just looked, with the first property and then the second property and an order for each. So let's take a look at a couple queries against both of these containers and see how it performs against the container without composite indexes and against the container with. The first query I'm going to run is getting the average price for all of my products where the category is outdoors. And you can see the average price is about $500 for the outdoor category. If I look at the query stats, my request charge is 320 RUs. And if I scroll down a little bit, we can see where all of the time executing this query was taken up. So you can see here that we spent some time looking at the index and about 95 milliseconds total. If we execute the exact same query, this time against our products composite container that does have those composite indexes, and if we just pull up the result a little bit so you can see, the average price still $500, so the data is exactly the same in both of these containers. But this time, if we look at our query stats, it only costs 51 RUs. So that's a lot fewer RUs than the 320 it took for the container with no composite indexes. If we scroll down, we can see where all of the time was spent. So if you remember previously, this was about 94 milliseconds, and now it's only 17. So we're really gaining a lot of performance by using the composite indexes, and we've also reduced the number of RUs. So we'll look at one more query example, and that is with group by. So this sample query is getting a count of new products for every category, and then we're bidding on first available of every 30 days. So essentially, we're getting the monthly count of new products per category. You can see here, I'm grouping by both category and by that date time bin function to have two group bys. Now, anytime you have two group bys, it's really going to show a lot of benefits for a composite index. So we saw how long that took on our container with no composite indexes. And we can switch over to our query stats. We see this cost about 38,000 RUs. And the time it took a long time to execute. So we see a pretty big index lookup time, a large document load time, time on the query engine execution, system functions. This took a really long time to execute. So let's see what happens if we execute the exact same query against our second container with the composite index. And you can see right away how much faster this is. So we have all of our results turned back, and it only cost us 5,000 RUs. Remember, the previous one cost $38,000, so this is really a big savings here. And if we can scroll down, we see our index lookup time did go up, but our document load time is now 0. So we were actually able to serve this entire query from the index, and we didn't need to load those documents into memory to process them. This is showing you really big savings. And the time for the query engine, system function, all of these times are also reduced. So when you add composite indexes, you can get a lot better performance for many of your queries. All right, let's jump back into slides. And we can take a look at a couple other optimizations that are really common. Let's look at queries that have array contains. So for this sample, we're getting a count of products where the address array contains Main Street. And that third argument is true for a partial match. So our whole address isn't Main Street, but the address property will have the street equals Main Street. When we do this, it's not considered a precise predicate because of that partial match. So we can't actually push the aggregate to the index, and we end up needing to load our documents to execute this query. We can actually rewrite this in a really similar way to make a better use of our index and get a lot better performance. So the logic behind the query is the same. What we're getting will be the same, but this is what our new query looks like. We're still getting the count from C, but instead of using array contains, we're going to use exists, and we're passing in a subquery. In that subquery, we're doing from our address array, where address.street equals Main Street. So the logic is the same, but you can see that it's written slightly differently. So let's actually hop back into the portal, and I'll show you an example using our products data set of how much savings you can achieve. All right, so we're back into the Azure portal. I'm going to switch over here, and I'm executing these queries against my products composite, but I could execute these against either container. We're not using the composite indexes for these queries. I'm going to go ahead and execute the first one. So here we're getting the count, and we're going to name this 5-star products, where our customer ratings array contains this stars equals 5. And again, we're passing true, which means it's a partial match. If you remember, our customer ratings also had a username. So we're not fully matching what the customer rating was, but we're just seeing if the array contains, 5 stars somewhere in that array. And you can see we have about 863,000 5-star products. If we look at the query stats, it took 24,000 RUs to execute this query. And we can see the times that it took. So our index lookup time, there was some time to use the index, but our document load time is really big. We spent a lot of time actually loading the documents in memory to execute that array contains and get you the right results. And then there's time spent in other places as well. If we run the equivalent query that uses exists, we can see how much more performant this is, and we can look at the time spent on the index. So again, right away, you can see this executed much quicker. And our 5-star products, the number is still the same. We still have 863,000 5-star products. But this time, our RUs are so much lower. So this only cost 18 RUs compared to 24,000, which is a huge saving in RUs. And if we scroll down, this is where we see the biggest benefits. So if you remember our index lookup time, we had some time in the previous query as well. Our index lookup time actually went down, and our document load time is now 0. We didn't have to load a single document to execute this. We could execute the whole thing from the index. And all of the other times to execute also went way down as well. So this is not to say you should never use array contains. There's definitely many valid use cases for array contains and for all of our system functions. But it's really important to look at how your index is being used and think about, is there a way that you can use the index more efficiently? Certain system functions will make better use of the index than others. And it's really important to think about, for your business logic, the answer that you're trying to achieve, what is the best way to write the query? So with that, let's take a look at a couple other resources that you can use to continue learning about queries in Cosmos DB. You can visit aka.ms NoSQL Query Get Started to get started with queries and learn a little bit more about how to use them in your workload. If you want to deep dive into composite indexes, visit ak.ms NoSQL Composite Indexes. And lastly, we have a lot of great resources on Azure Cosmos DB Live TV if you're a visual learner. There is a deep dive of this very session content in episode 71 if you want a longer explanation of a lot of these concepts. Thank you so much, and I hope you enjoy the rest of Azure Cosmos DB Conf.
It's pretty convenient to go to a virtual event. Of course, I love in-person events. My favorite in-person event is PGConf EU, but not everybody can go if it's in person. If it's a virtual event, travel isn't even part of the equation. Money's tight. You don't have to pick. You can like in-person and virtual events. CytusCon talks on YouTube, I just watch them at 2x speed. I don't think you're the only one having trouble getting travel approvals. You won't need to file an expense report. I'm just saying that when you attend a virtual event, you get access to phenomenal speakers from the comfort of your own desk. Everybody can participate if it's virtual. Really high quality production values. Captions, 2x speed, 2x speed. Have I mentioned the production values? I like to make an espresso first. So you prefer 1.5x speed. Captions are like the perfect example of the curb cut effect. I like both. I'm not going to pick between in-person and virtual. I'm going to like them both.
Welcome back. Let us know what you thought of those first two talks. Tara, what'd you think?
I thought they were awesome. Learning directly from people on our team, that's so cool. Like, where else can you get that? So yeah. What about you, Deborah? What did you like?
Yeah, that last talk about how to reduce your RU costs by tuning your index and optimizing your queries can save you a lot on RUs and make your workload more efficient. So really great advice there. Let us know your thoughts and comments on Twitter or in the YouTube comments. Again, hashtag Azure Cosmos DB Conf. You want to check in on some of our shout-outs so far?
Yeah, for sure. We have a thief here tuning in for the Cosmos DB conference. We also have Chris, who's chilling with his cat on the couch, streaming some Azure Cosmos DB Conf. So bring it in. We want to see where you guys are watching from, who you're watching with, whether you're watching at home, in the office, if you're watching with some furry little creatures, like bring that in. We want to see all of that as well.
That sounds so nice right now. All right, we've also got a lot of great comments on YouTube. We've got Sumit Simgupta, who said, great innovation. This is referring to the Azure Cosmos DB for MongoDB vCore offering. Reminds me of DTU to vCore for Azure SQL. And then Roland G says, hello from the land of Kansas, home to Learjet, Cessna, Beechcraft, and Boeing, home to Komen, Pizza Hut, and Ted Lasso.
Love that show.
All right.
Cool. So I guess like you've hosted this conference in the past. What were some of like the highlights in previous years of Azure Cosmos DB Conf?
Yeah, I think the highlights, again, I feel like I sound like a broken record, but again, just the customers. I feel like every year there's different and new customer use cases. Like this year, hearing about, and like, you know, Microsoft Teams, right? Like, I feel like sometimes like I spend my whole day in Teams and just knowing that Cosmos DB is backing it is really awesome. The ChatGPT, OpenAI thing, that's definitely new this year. It was not there past couple of years.
Yeah, so definitely. And I'm sure Cosmos DB helped so much with their like increased traffic from just like January to March. So that's very exciting. Yeah, cool. Who do we have next, Deborah?
Yeah, let's go to our next two talks. So first up, we've got Brian Benz, who will share how you can use Azure Cosmos DB along with Logic apps and some AI services in Azure to track data and images for a pretty cool use case he's going to show you.
Awesome. Yeah, after that, we have our very own Stephanie Arroyo, who will be talking about log analytics. And both of us will be back after the talks to share what you've got to say about the show. So keep it coming. Cool.
Greetings, everyone. I'm Brian Benz. I'm a cloud advocate at Microsoft, and I'm here to talk to you about using Azure Cosmos DB, Logic apps, and AI to store and track images. I'm going to jump straight into the demo. I've got a few things that I want to show you that are pretty cool. The first thing is up here in the Azure portal. The Azure portal, if you go to portal.azure.com, for those of you with an account, if you don't have an account, you can sign up for a free trial there. And this is essentially what I've done to build the demo today. I've got a Logic app, and I've got a Cosmos DB account. I've also got a storage account and a bunch of API connections that I've built. And I'll show you why I did this and how as we go along here. It all started when I saw that the United States Postal Service has a new service. So apologies for those of you who are outside the US who don't have this service, obviously. You might have something equivalent with your own local post office, but basically what it does is it allows you to set up an account on the US Postal Service website. You verify your identity, then you start getting emails with images of your actual mail. It usually comes the day before it's going to arrive, so it's kind of handy. You know what's going to come to your mailbox. This is some samples of what the mail looks like. And once again, you might have something in other countries that is equivalent, but basically, this is a really good one. This is the best quality image that they send. Each image is sent as a JPEG image, which is kind of handy for processing. So what I thought is, all right, this is interesting. I signed up for the service. I'm getting it. How could I actually start gathering statistics on the mail I've got? Am I getting a lot of junk mail? Am I getting a lot of mail from a certain credit card company or a bank? And start collecting info on what I get in the physical mail so I don't have to keep track of it so much. Did I get something from somebody a month ago? I can look it up, that kind of stuff. So kind of virtualizes your mail. So anyway, this one is nice, full color. Then you got a little more challenging image here. You can see this is the quality of the images and how they actually get delivered. It's fuzzy. They're not high quality images. And here's one with tons of challenges, right? So this particular one has a postmark over top of the return address. It's got some diagonal text, and even this down here, is Cosmos, are we going to be able to read this using optical character recognition? And this is the challenge I had. So this is what I decided to use. I use Azure Cognitive Services Computer Vision, and Computer Vision service has algorithms that basically enable OCR, optical character recognition. The optical character recognition extracts text from images, just like it says right here. And you can use the read API to extract that. So perfect, that's what I wanted to use. Well, how do I actually automate that though? How do I get it from my email inbox into an actual piece of data that I can use? Well, I used Azure Logic Apps to do that, and I used Cosmos DB to store the data. And there's a couple things in between that I do as well. Azure Logic Apps is a way to automate with very little code, in this case, no code, different processes based on triggers. And so I'm using a few different triggers here to actually make this work. And the solution looks something like this. So this is the Azure portal once again. If you go into your resource group, there is an actual imager that you can see. So this is a sort of a hierarchical image of our resource group that we're working with here. It's got something called Cognitive Services. I named it Read Mail. That's my name. The Cognitive Service is the actual tool that's used to read the mail. I've got a Cosmos DB account, which is where we actually store the data. I've got the Logic app. The Logic app actually works with several connections, and the mail reader itself is a storage account. What happens, this is a little trick, when you're using Cognitive Services, it has to actually have a physical location where it can find the thing it's working with. And to do that, I had to use a storage account in this case. There is a new feature as of October 2022 that allows you to have streaming. So you can use video and images and things like that streamed to the Cognitive Service. But at the time I built this, the capability wasn't available. And also it's good for troubleshooting to have the original image stored somewhere so you can refer back to see what went right, what went wrong when it comes to processing the image. So that in a nutshell is the structure I have here. The Logic app connects to storage, it connects to Cognitive Services, it connects to Outlook, and it connects to Document DB, which is basically the connection that we use to connect to Cosmos DB. All right, so the Logic app itself, this is the Logic app. The way I set it up is inside of Outlook, you can choose to put incoming mail into a folder automatically. In this case, I put it into a folder called Mail Reader 2020. And this particular Logic app, when it's running, is enabled to basically monitor that folder for any new email that arrives. Include attachments, you say yes. And then for each attachment, you create blob storage, and you create it in something called a container called mail reader inbox. You store the attachment blob is going to be the attachment name, so the name of the image that gets stored. And you can store some context. In this case, that's the actual image. The next thing we do is, now that we have this in the blob, that triggers another piece of the workflow. When the new item goes into the blob, it actually passes an ID. So it takes the ID that was created when this image was put into storage, and it passes it to a for each condition. That for each condition says every time there is an image, and I had to make this image equal to JPEG. That's a little tip, because there were some other things that were attachments in the email, that were advertisements and things like that, that weren't JPEGs. And if that happened, the character recognition choked on it. So I made sure each time there is an image in the attachment that is a JPEG image, that means that's a image of mail that's being sent to me, we trigger optical character recognition. So the first thing we do, Outlook, a new item in the folder triggers blob storage. And then a new item in blob storage triggers the for each condition. That for each condition processes the blob. It gets an ID, and you're going to need that ID later for Cosmos DB. So that's why you do that. Then you take that file content, which is the image, you pass it to optical character recognition to JSON. This is a pre-built condition that's in a Logic app, and that returns a JSON document. Now, on top of that JSON document, once that's actually created, we pass that JSON document to Cosmos DB. So this is the Cosmos DB part of the Logic app. We go into a database called ReadMail, collection ID ReadMail1, and we have a document that gets created. The actual document is down here in the attachment ID and the response. So that's actually the OCR document. Everything else here is passed from blob. And I just decided, because I could, to pass some statistics from the blob. And this is really useful for troubleshooting if the OCR is not going the way it should. So if you see just garbage coming into your JSON document in Cosmos DB, you can go back, trace this through to the blob, and open the image and check out what was that original image and why is it having trouble reading the OCR. Okay, so you add a E tag, a location, metadata, attachment type is, in this case, JPEG, and just bookmark that attachment type because it's important. And then you take the attachment ID and the JSON response, which is the actual generated OCR from the document, and you pass it an ID. The ID is critical because you need, remember I kept the ID from blob storage and I passed it into here. The ID is critical for creating a unique ID in Cosmos DB. Every entry that you have in Cosmos DB has to have that unique ID. So we actually use the original blob ID. So that once again makes it easy for tracing back to the blob too. Then you have a partition key value, which is required in this particular instance. And the partition key value is always going to be JPEG. So we're just using a media type JPEG, but it could be anything that helps you build partitions based on your storage strategy. All right, that's done. So basically that in a nutshell is what happens. You retrieve the email, you do the for each attachment in that email. And inside of that for each, if there's a JPEG image, you get the OCR, you get the blob content, and you pass it over to Cosmos DB. And inside of Cosmos DB, here's a sample. This is the top part of it. And it just tells you what the E tag, the blob location, and all the details are without getting into the actual mail, which has my personal information in it. But you can see how that works. This is a really brief overview. If you need more details, I have outlined this in a blog post that we covered last September, in Serverless September, called Logic Apps and Computer Vision. And it outlines everything step by step that you need to make this work. You can also find that at aka.ms/Cosmos Mail Reader. And I've got a few other links here, but that's the one you need. aka.ms/Cosmos Mail Reader will take you to the step-by-step that you need for this particular example. So that's using Azure Cosmos DB, Logic Apps, and AI to store and track images. My name is Brian Benz. You can find me on Twitter, Mastodon, GitHub, and a few other places at bbenz. And I welcome your questions.
Hi everyone, I'm Stephanie and I'm a PM on Cosmos DB. Today we will explore the piping hot world of monitoring and observability and how you can leverage our new log analytics workbook to help you put out any burning fires. So as engineers, we all know that fires are bound to happen. This is where observability comes in. In observability for Azure, we have three main pillars: metrics, which are near real-time analytics for monitoring your requests. This data is typically aggregated up at a minute plus grain. We also have logs, which are per request, more finer-grained raw logs with richer dimensions than metrics, and it is a paid offering. And finally, we have alerting, which allows you to trigger notifications on top of data sources like metrics and logs. For the scope of the session, we'll talk about log analytics and specifically dashboarding with Azure Monitor workbooks. Now, before we go into the workbook itself, let's quickly chat about some common issues or fires customers typically investigate. For example, I'd like to know what my expensive query operations are, and why am I being throttled, or how much of my workload is being throttled? What are my long-running requests? Do I have a hot partition, and how do I see my hot partition at the logical partition level? And do I have a storage SKU? Which partitions, if I do? These types of questions are exactly what our new Log Analytics Workbooks integrations will help us answer. It is an out-of-box dashboarding visualization for our logs, and the best part is that it can easily be customized for your needs. So these are the types of questions we will want to answer with our Log Analytics Workbook. So let's dive in. Let's say we have in our workbook for insights, we see that there is some spike that happened. Sometime around in March, around 10:30 p.m., we saw utilization spike up to 100%. And we want to investigate further about why that happened. Let's go into our Log Analytics workbook. Here, what you'll notice is that the time range, you can select the last 24 hours, or you can even select up to a custom time range, going back to whenever you know the incident occurred. In this case, I'll set it to the last 24 hours. You can also select your database and a specific container if you know where it is. One thing to know is that when you do turn on log analytics, you have to select a couple of different category groups like data plane request or partition key RU consumption in order for you to use this workbook. Additionally, we also have another feature called full text query, where you can actually view the entire query deobfuscated for your Cosmos DB account. Now let's dive into a couple of different examples. For log analytics, if you want to see your logical partition based on your RU consumption, you could actually view, this is the exact query that we use within log analytics, but we actually have it here in the workbook for easier viewage. For example, we have here your logical partition. In this case, I have partition by sensor, and we see around this time, the sensor 2 is actually the highest out of all the partitions, and very little usage in the other ones. We could also see queries with the largest response lengths. So this query is querying the CDB data plane request table, and you could actually see the query text that I ran and the max response length. And this response length is in milliseconds. In addition to this, if you want to see what operations are taking longer than 3 milliseconds, you could also look into the data plane table and look for a duration greater than 3, and also summarized by client IP, so you know who actually queried and at what time. Also, you can look at storage. So if you want to see storage skewness, you can see, as mentioned above, that for my logical partition 2, where sensor ID equals 2, we actually see the usage is very, very high compared to the other logical partitions. So this could mean that at some point there was some spike of usage for this particular logical partition, and we want to investigate what happened there. To do that, we can actually see here, the request charge also map up that we see in this particular one partition. We actually see a lot of request charges, and this is by physical partition. So partition key range ID is actually the physical partition, and just looking at the raw data, this is actually the top with request charge really pretty high compared to the other partitions. So now let's try to look into what could possibly be the culprit. At that point, you saw that normalized usage was very high, and we also saw high rates of 429s, which are throttled requests. So if you look here, actually most of the 429s that occurred were create operations, which tells us that during this time, around 10 or 11 p.m., there was a burst of create operations during, in our collections, which caused that spike. So you can then investigate further whether this was expected, or was this some other workload that started running unexpectedly, which caused a spike. And finally, one more interesting thing is if you want to look at your queries or how to optimize it, you could also use log analytics to query the data plane request table to view every query text and also what the charge was for that particular query. So you can sort by largest request charge and then sort of use that to optimize particular queries. So if you hover over the exact query text, you can see that I ran a query where I ordered by light and temperature, and this is another one that you could optimize if it was very high. All right, and then one last thing I wanted to share was, if at any moment you have, let's say you already have some log analytics queries, one really cool thing about workbooks is that you can edit this workbook, and you can select edit, and then each of these items or groups can be edited, and you can add in your own queries if you already have some complex or queries specific to your workload. All you have to do is select this more. You can clone this particular group and then scroll down and select edit, and then actually you could just edit this query, copy and paste the query that you have already, and then run it, and it will actually save it for you. And then you can save this in your own log analytics workspace, which is pretty handy. All right. Now that we've actually troubleshooted what was the issue, let's go back and let's talk about costs with log analytics. So log analytics, as you saw, can do really great things for investigating and troubleshooting issues, but it can get quite expensive. And so this feature is actually charged by the amount of data that is ingested into the workspace, very granular. So for example, if you have 10,000 requests per second, in one given hour, you could actually go to about 14 million requests, which is actually pretty high in terms of data ingested into the workspace. So to help optimize costs, we now have transformations in Azure Monitor, which will allow you to modify or filter out incoming data before it is sent to your log analytics workspace. With these transformations, you will be able to delete any unused columns, decrease data that is ingested into the workspace via filtering out entries that actually don't fall into your criteria, and things like only 429s or requests that fall above a particular threshold, and even creating new columns or aggregating data. Let's go over how to add transformations to your workspace. So here we have our log analytics workspace. What you'll do is go in their settings and under tables, and if you scroll down, you'll be able to go to see our Cosmos DB log analytics tables. We have a couple of them for NoSQL API. Some that are relevant are the CDB data plane table, the partition key RU consumption table, and the partition key statistics table. So for this exercise, we'll look at the data plane request table. So you can scroll and then you can select the edit transformation. In this case, you'll hit next and you can, I've already created a transformation, but you can hit transformation editor. And this actually gives you the table that we'll be querying. So if you query source, which is the base table, source will give you a lot of details, things like your account, the time generated, activity ID, client IP, connection mode, database name, how long the request took to execute, operation name, partition ID, and a bunch of other handy information. So what we'll do is actually we want to compress this table. So I'll copy over a sample query here, where just taking a quick look at the actual table, we see potentially we might not need some of these columns like key type, something that maybe not very valuable for me right now. Connection mode, if I'm running direct mode and I'm using the SDK, I probably don't need to investigate that. And then I could also remove type and tenant ID, things that are just taking a little bit more data into our workspace. So if I run this, you can actually see that the table is quite small compared to where it started. And then what if I only want to look at requests where duration or the time it took to run the request actually only 200 milliseconds. So this actually gave us a pretty small table, but what if we want to further filter out rows that are coming in, and we could actually use a property called response length. What if we only wanted to look at a request where response length was actually greater than 1,000? In this case, this actually lowers down the results significantly, which actually gives us a lot more savings and optimizations into the data generated into our log analytics workspace. So now that we have our transformation applied to our source table, we can then hit apply, run the query, and then you can select apply. And I've already done this for this particular resource, but it will take about 30 minutes for the KQL transformation to be applied to your workspace, and then you'll be able to have a much more cost optimized logs. Thank you so much for your time, and I hope I was able to help you extinguish any fires in your service.
I'm Alex Amante. I work as a full-stack IoT developer at Spark, New Zealand's largest telecommunications and digital services company. What really stood out for us about Azure Cosmos DB for PostgreSQL was the ability to horizontally scale our database to ensure that our customers' data is always available to them 365 24/7. Our developers are able to integrate Azure Cosmos DB for Postgres with all the other services in Azure, like IoT Hub and static web apps. This helps us reduce the amount of plumbing required and lets our developers focus more on the business logic and solution instead of the infrastructure.
Welcome back, everyone. Those were some great talks, and I really enjoyed hearing from Alex from Spark on how they're integrating Azure Cosmos DB in their products. Also, super cool to hear that there are more workbooks that are live and published. A great talk by Stephanie explaining how to fight fires with log analytics. And it's so cool that we finally have so many workbooks that users can use to troubleshoot their workloads on Azure Cosmos DB. You can pretty much use them to help you lower your costs and just analyze more metrics on your Azure Cosmos DB workload. What did you think about the past two talks, Deborah?
Yeah, I love those two talks. Log analytics, again, is super helpful for giving you that per second view of like literally at this time and second what is happening in my workload right now. One thing that Steph demoed that was super cool that I actually hadn't really seen end to end before that talk was how you can actually filter the raw input of log analytics to only emit the data that you actually care about. So if you're only looking for queries that were more than, let's say, X RUs, you can ignore all the other queries that were fine, right? Only log the things that you actually care about. I also really enjoyed Brian's talk as well. I think it's awesome to see, Azure Cosmos DB is a database, but it's not just Azure, right? It's not just Cosmos DB. There's so many other components and services in the Azure platform, like AI services, logic apps, and gluing it together to solve a problem we had. If I did that same thing, I would have a lot of junk mail. That's probably what mine would say. All right, so if you missed any of these sessions or just want to rewatch them again because they're so awesome, please check out the on-demand content at aka.ms/Azure Cosmos DB Conf/collections. Or on demand. You'll find it. You'll find it. So there are a ton more talks to come, and I think we also have a questions from viewers, but let's do some shout outs and take a look at what's going on in social.
Yeah, awesome. We have someone all the way from Sydney, Australia watching right now. Shout out to Mina. Thank you so much for watching. It's probably like 3 a.m., 4 a.m. over there. So thank you so much for watching. We love how supportive our community is and how engaged all of you guys are. So we'll definitely keep in mind for other time zones in the future, but thank you so much for watching. We also have someone from Brazil who's watching, and they're very impressed with the new vCore features. We've had a lot of buzz around MongoDB vCore, and we're so excited that this is finally coming out, and it's been a long time waiting as well. Yeah, I think there was a question about hierarchical partitioning, which Deborah will be talking about as well.
Yeah, definitely. Before that, I also want to give a shout out to Papulo, who's a Microsoft certified trainer with a special interest in data and cloud technologies, and they're watching this event from Nigeria. So thank you so much. It's awesome to see the global audience. Cosmos DB is a globally distributed database, but so is our community and our customers. All right, so I saw there's one question from YouTube about hierarchical partition keys, also known as subpartitioning, really asking about when is this feature going to GA and what's the future of the feature. We're definitely plan to bring this feature to GA. For those of you who are not familiar with it, hierarchical partition keys is a way for you to use up to 3 levels of keys to basically partition more optimally for multi-tenant scenarios where you might want to partition by tenant and then subpartition by something else like user ID. So we've had a lot of great feedback both from our internal and external customers on this has really helped them optimize their workload. It makes queries more efficient, makes queries faster, and just overall better for more optimal solution than what they can do today. So stay tuned for more exciting announcements there. Definitely, you'll expect to see something coming up.
Yeah, we're so glad that this is a feature that's really resonating with our users. Glad to see that someone said that it was working super fast for them, and so we're very excited to see how you guys use this and how it affects your workload so we can constantly make improvements. If you guys have any other shout outs for other features that you've liked using on Azure Cosmos DB, please let us know in the chat, let us know on Twitter. Again, the hashtag to use on Twitter is hashtag Azure Cosmos DB Conf. And we'd be happy to give you guys more shout outs and also use that feedback later on during our internal meetings to see what's working for our customers and what's not.
Definitely. And by the way, just as a shameless plug, we actually have an on-demand session delivered by myself that covers demo of hierarchical partition keys as well as some other great features to help you optimize your workload, help you save on cost, and use just the rest of the Cosmos DB surface area.
Yeah. Awesome. So now it's time to hear from some of our Azure Cosmos DB customers, which is all of you guys. We want to see how you guys are using this service for your applications and for your workloads as well. So first up, we have Daniel Zafar from Databricks, who will be talking about how Walgreens is actually working with Azure Cosmos DB.
And then next up, after that, we'll have Raj Tuteja, who will talk about how Mars Incorporated uses the Azure Cosmos DB change feed.
Yeah, looking forward to it. Let us know what you guys think, and maybe in the future you can also see yourself here at Azure Cosmos DB conference presenting what you use Cosmos DB for. Yeah.
Hey there, my name is Dan. Hope you're enjoying the conference thus far. I am going to be telling you a little bit about a Cosmos DB use case at Walgreens. So with this, I'm going to be speaking to expanding the bulk patch functionality with Walgreens, especially using Apache Spark. Jumping right into it, my name is Dan. I'm a resident solution architect at Databricks. I've been at Databricks for over 3 years. So what I do at Databricks is I help customers be successful implementing data pipelines, and that can require gathering requirements, making architectural suggestions, or implementing architectures, hands-on coding, as well as the documentation, testing, everything else, managing other developers. I'm a really big fan of the the data lakehouse paradigm, which Databricks sort of pushes. So I think that the best data warehouse is a lakehouse. Make sure that all of your data is in open file formats and easily accessible for BI, ML at scale. So I'm a big fan of Spark Structured Streaming, for running data pipelines, Delta Lake, Scala, functional programming, and the autoloader ingestion framework. If you haven't checked that out, you're a Databricks customer, definitely recommend it. It's super slick. So I can give you a little outline for my presentation. First thing I talk to you about, what was the Cosmos DB use case at Walgreens? It's with the prescriptions. And then I'm going to tell you about the proposed data pipeline architecture that we set up. Then afterwards, I'm going to go into some of the complex issues that we faced. And some of the stuff is going to be super technical, but I'm going to go through it fairly fast. So first, I'm going to go through some of the known complexities that we had coming in that were just artifacts of our architecture. Next, I'm going to go into how we solved one of these in detail, which was expanding the bulk patch functionality, the namesake of this presentation. And finally, I'm going to talk about some of the unknown complexities. And these are the things I really encourage you stick around to see these, because I wish I had known these things when I started this project. They were definitely caused a lot of last minute changes during integration testing. So hopefully you don't have to run into the same issues. So let's go into the use case. So the idea here for this project was that we wanted to make the on-prem prescription data available to the Walgreens Pharmacy mobile app. So for instance, let's say that you have a prescription, you should be able to look in the app and be able to see, this is when the doctor sent this is when it's available for pickup, this is all my prescription history. All that needs to be accessible at a 1-second lookup time SLA. In addition, the requirement was that we needed to make sure that we had a 2-minute end-to-end SLA coming from landing in the centralized data warehouse going into Cosmos DB. So we chose Cosmos DB for this really because of that 1-second lookup SLA from the mobile app. Since Cosmos DB is geographically distributed, highly concurrent, multiple users can be pinging Cosmos DB to get the information for their prescriptions and refill histories. Other requirements is that the data need to be processed in the correct sequence. So this is essentially a change data feed sort of pipeline. So if we process things in the wrong sequence, sometimes we can have data loss, which we want to avoid. Another big requirement is that everything is going to be end-to-end voltage encrypted, which is something that made things a lot easier from the developer side nominally. But, and this is something I'll get into a little bit later on, it actually caused some pretty big hiccups from the Cosmos DB side. So next I want to go into the data pipeline architecture that we proposed for this. So as I spoke to before, everything is landing in Oracle, which is on-prem. It's a big sort of legacy system that's handling all of these sort of transactions coming from new prescriptions, new fills, all the different details. This is going out as a change data feed into QLIC. And then QLIC replicate is being used to send all the change data into Kafka. Into Kafka, the data is normalized. It's split into 5 tables. These tables include different aspects of, this is the prescription with its, this is the medication and the patient ID. This is the fill information is in another table. The exception information, like for instance, if there weren't enough of some medication somewhere, or they had to make some sort of change, some exception, this is going to be another table, and then other details are covered by other tables. So what's happening basically in this pipeline is that the information is coming in a normalized format, and then we're writing it to Cosmos DB in a denormalized format. So the idea is that everything's going to be into one big nested schema. And so when the mobile app needs it, it can go to Cosmos, just get the information it needs, don't have to do any additional joins, and then serve the data to the customer. So the way that we do it, and this is very simplified for our architecture, is for each table, we get the Avro encoded data, then we use the Confluent schema registry to actually decode all of that Avro. Then we roll it up. I'm going to go into roll up in a subsequent step, But the idea being for each table, we might have multiple records per microbatch. So we need to roll it up so that we only do one write or update per microbatch for each primary key. Now, and then after that, we're going to do our insert writes and our update writes. And I have those actually separated out because we needed to use a different API for those. The inserts, we could use the upsert of the item patch API. The updates, we actually had to do ourselves. Finally, you can see that there's two collections in Cosmos. There's two collections because we wanted a really fast lookup time. The trade-off we made is we wanted to throw a lot of resources at it and actually duplicate our collection in Cosmos DB, but just with different partitioning schemes. That way, the microservices could actually pick these up very quickly. So let me talk a little bit about the known complexities. So this is a representation of the table as it comes after everything is brought in from Kafka. You can see that the different tables are going to have different entries as different rows. And in addition to that, we're going to have different CVC operations. If you see, like for instance, with this one, these are two of the same ID, like the same primary key, but they have different CVC operations. So the first thing that we had to do is set up the aggregation logic. For the aggregation logic, we'd actually need to combine these two rows to be one row because we don't want to go through and for every single row write something to Cosmos DB. We'd have to worry about ordering. And also that'd just be a lot of writes. Instead, we want to aggregate it so that for each table and for each primary key, we're only going to have one write to Cosmos DB. So in this case, this insert and subsequent update would turn into just a new insert, but the records would be null A, null H, which is combining the data from both. So we solved this using the aggregator API with Scala Spark, which is basically like a newer version of user-defined aggregate functions. The other thing that was pretty hairy and which I'm going to go into the code for is how we handled partial updates. So the problem with these like CDC data is that when we get an update, we don't get the full record, right? We just get a partial record. And you can see that there's this change mask here, which is 1100 ellipsis. What this means is that the positionally first and second element are actual changes to the data for this primary key. The rest of them are just null, they're just placeholders. And that's just a function of our Avro schema, right? So the challenge faced with this is that if we're trying to update a bunch of these records at once into Cosmos DB, we can't use an upsert, right? Because then it's going to overwrite all of the fields that aren't in there. And then we can't really use item patch either because we're trying to, different rows are going to have different fields that are changing. So how do we handle that? The way that we solve this is actually by extending the bulk update functionality ourselves, basically re-implementing some of the connector ourselves. Hopefully you don't have to ever go down that road because I was communicating closely with the Cosmos connector team, the Spark Cosmos connector team, and Fabian. I believe they are going to roll this into the product to be able to use the change mask. But in the meantime, it was really cool and I'd love to show you about it. So this is how I sort of achieved it. This is a lot of code. I suggest, I'm not going to go everything in detail, but feel free to, if you're watching this down the line, you can stop the video and go through it. But essentially what's happening here is we're going to get our data frame, and then we're going to coerce it into a format such that the data frame is usually going to be rows where each row is going to have a lot of fields. Instead, we're going to explode it. And so I'm manually exploding it into a certain format that I'm going to use to write it afterwards. So basically what happens is I do a flat map to explode, and then I get it such that for every row, row quote unquote, we're going to have an ID, the key, and the value. So that's going to be what's the primary key, what's the field name, and what's the value for that field. And then I have an optional thing for if it's nested, which is basically just a modifier for handling if it is a nested field or not. And then I'm going to filter that based on the changed mask. So I'm going to basically zip it with the changed mask and then filter based on that value. So after I have it in the Cosmos write row format, I'm going to write it. So to do the write, we actually just use the Java SDK here. So what happens is we have this exploded data frame. We basically are using the RDD API here to where we group it by field. And then for each field, we need to actually apply the correct data type that's in Cosmos, because we can't write them all as string. Some are going to be integer, some are going to be this or that. So we get the data type and we coerce it. We apply the right type to all that data, and then we actually write it at the field level. So the cool thing about that is that instead of writing each row one at a time, which is going to scale based on the size of the microbatch, it might not be that scalable. What we're going to do is actually we're going to do one write using the Cosmos bulk operations get patch items operation API. We're going to do one write per field. And so that's great because it's actually going to be limited to what's in the schema, which in the case of Walgreens was only like 200 or 300 possible fields that could be written to. And then under the hood, we were just using sort of like the Flux API, and we were setting up our own Cosmos connection and executing the bulk operations in async. So that's basically how we achieved it. This is pretty high level. This is pretty low level, but I wanted to give some idea in case folks run into this in the future. So moving on, I want to talk about some of the unknown complexities. So these are issues that came across afterwards. So when we were doing integration testing, we kept on finding error 400 bad request. So one of the reasons why this was happening was because of our voltage encrypted data. If you've ever worked with voltage encrypted data, you know that it actually will spit out a lot of weird characters like / and \. One of the things that we found out about Cosmos DB is that you actually can't have a / inside of your primary key. If you have that, it's not supported in a lot of use cases. In our case, for writes, we couldn't do it. It actually corrupted some of the operations inside of the Spark Cosmos connector. Our solution, we just encrypted everything in MD5. MD5 doesn't have any of those bad characters, so we were good. Interestingly, you should know, there's no restrictions on what's in your partition key. So we didn't have to do any sort of MD5 encoding on partition key, which was, it was sort of like a silver lining. It made things a little bit easier. The other thing that we ran into afterwards is that our partition key had to be populated during item patch operations. So usually when you think of a key value store, you think the primary key is going to be unique across the collection. In Cosmos DB, that's actually not true. It's the combination between the primary key and the partition key is going to be unique. You can actually have multiple primary keys for a given partition key, or you can have multiple primary keys for a given partition key, but across partition keys, you can actually have the same primary key. So this actually was a big issue for us because one of our collections, the partition key, had the patient ID, and the patient ID was only in one of the tables. So to get around that, we actually had to do a big read from Cosmos to get everything before writing, which is something that we were trying to avoid the entire time. So anyway, this is these are some of my important takeaways from this project. Thank you for watching the presentation. I hope that was useful for you. I hope you don't have to deal with some of those issues at the end, like knowing that you need to write with the partition key and the primary key both for item patch, and knowing for the special characters. I hope you got something from it, and enjoy the rest of the presentation. Feel free to reach out to me if you're looking at this, 6 months or 1 year in the future. Feel free to LinkedIn me. I'm happy to talk about anything. I'm happy to hear from you. Appreciate it.
Okay, hello everybody. So I'm a PM in the Cosmos DB engineering team, and I lead the program work for the JVM ecosystem, or what we call the JVM ecosystem, which maintains some open source projects, including the Java SDK for Cosmos DB, the Spring Data Client Library, the Spark connector, and the Kafka connector. And I wanted to invite Raj, who's an engineer from Mars Incorporated, who I worked with and has also been working closely with our cloud solution architect team, Jaladi and another Raj from Microsoft. And they had an interesting challenge, which involved first selecting one tool and then course correcting to another tool. So I won't steal his thunder anymore. I'll just hand over to Raj and let him talk you through this scenario.
Hi everyone, I'm Raj Tuteja. I work here as Senior Manager of Data Engineering, and we will go through a few slides, talk about how we can stream data easily from Cosmos change feed to ADLS. So let me start with the slides here, and we will talk about, and we will have a code walkthrough as well. All right, so the first thing here is what is Cosmos change feed? So as you know, Cosmos change feed is a persistent record of changes to a container in the order they occur. It then outputs the sorted list of documents that were changed in order in which they were modified. And in this session, we are going to talk about how to stream that data. All right, so our business requirement, we have over 15 databases in Cosmos and over 100 collections. And we wanted data to be presented to our users for operational reporting near real time. And some of those examples would be when the status of a patient changes, we want to notify our downstream systems right away that status of the patient has changed. Or when the new appointment slots become available, we want to notify our field operations that new appointments are available. So those were some of the requirements that we had so that we can report data near real time. So Theo mentioned we looked at a couple of approaches. The first approach that we were working on, or we tried, we were taking data from Cosmos using Kafka Connect, and we had that data in Azure Event Hub. And from Event Hub, we created a Kafka stream through Azure Databricks to stream that data into ADLS. So this was our first approach that we tried, and because of the size of the data, number of databases that we had, and the requirements for near real-time availability of data, it required a lot of ports allocation in Azure Event Hub. And the memory allocation was very, very high because we had multiple environments, dev, test, prod, and all those environments required similar setup so that we can develop, test, and before we put it to production. So this was our first approach that we tried. And then we tried our next approach. You see this looks much simpler here. And we are using here Azure SDK for Java. And Azure Cosmos DB Spark 3 OLTP connector is part of the Azure SDK for Java. So we can read the change feed directly from Cosmos here using this library from Databricks and store that data in ADLS. So it renders both the Kafka Connect and Event Hub basically redundant. So you have two less moving parts. You don't need to allocate such a high memory. So you save the cost and setup time. And this one actually works better here for us, at least for our requirement. And the connector is available in Azure Databricks, and each stream can be run on its own job cluster, and that provides a lot of flexibility and scalability. So if your if your streams are like some streams in our case were like maybe a couple of records a day, and other streams are millions of records a day. So you can easily scale up your clusters depending on your streaming needs. And in the next slide, we are going to take a look at a code snippet here. So you can see the library provides a lot of options. So we can go through those options here, some of them. The first one here, you see we just need to provide the Cosmos account endpoint, the account key, how to connect so it can authenticate and authorize you, which database you are pulling data from, the container that you are pulling data from. And if your setup is in a private network, then you need to set the gateway mode. And there are quite a few other options how you can stream data, from which point you want to start, and all those configuration options are very well documented. And here you see you just need to do spark.read stream and pass your options, the read options here, and you can start streaming data. So once you have your data frame created that is reading data, you can write that data frame with the write stream options here. And so it works very well out of the box. So you have these options available, and the configuration options that we are going to talk about are very well documented. As I said, you can go through these links here. So the configuration parameters, and there are quite a few samples available here, and some of the main documents on Microsoft website that can be helpful as you implement these changes. So in our scenario, we faced a couple of challenges initially. So our setup is all in private networks with the VNet setup. So we had to set up that gateway mode I mentioned earlier to true, so that it passes data or it passes the data through the firewalls and uses port 443. Otherwise, it can use multiple ports from Cosmos. So there could be some performance challenges if you don't partition your tables correctly, because as you stream data, you are merging data every time to your target tables. So make sure you partition your tables correctly. Another challenge could be if your cluster is not sized correctly and the memory allocation is not appropriate, depending on your data size, there could be multiple reads from Cosmos because the data is not persisted in memory yet. So make sure you have the data persisted so that it doesn't read multiple times. The checkpoints, that's another important part. So you can store the checkpoint, and if you want to stop your stream and restart it, it will restart from the checkpoint. You also have the option of clearing the checkpoint, and then you can read from a certain point from your source if you want to reset some of that. Right. So we will do a code walkthrough. Before that, I want to just show one more thing to you. I mentioned there are a lot of configuration options available. So these configuration options are documented very well here. So you see all these options, generic configurations, AAD authentication, configuration. So all of these are very well documented. So you can go through those links and figure out which options work for you. And I'll show the actual code now with the running stream. So this is our actual code. We are running this stream here. I'll go through the stream first. So you see at the bottom here, the change feed is running here. And we are doing as of now, it's not streaming any data really, but the streams are running. So going through the code a little bit here. So the way we run it, we have just one notebook and we pass parameters for our different streams to this notebook as we schedule these jobs, and those jobs can take different parameters depending on which stream we are running. The first one here you see, we have the unique keys identified, what mode we want to run. So we are passing all those parameters, reading these parameters here. So this is our actual code running in our production environment. So we are logging some of those streams as we go through it. I showed the code snippet earlier, and you can see here we are writing the streams after we read it from here. So this is the read stream and this is the write stream. So you can see we are writing the stream after we read the data. So it's very straightforward, very simple. And as I said earlier, we struggled a lot when we started with Kafka because of our data size and the number of databases that we had. We had very high board allocations. The memory consumption was very high. But with this library, it looks very straightforward to us. And we are happy that we connected with you and we were able to use this.
Okay, thank you very much, Raj. I really appreciate you taking the time to show your work and to show how you solved this problem and the steps that you take and that you took and how you had to navigate through one thing and then course correct to another thing and how that worked out for you. So I really appreciate that. Hope you enjoyed the presentation and hope you enjoy the rest of the conference. And thanks for watching.
Thanks.
Hello, I'm Joni Ness. I'm the CTO and co-founder of Zero Friction. So Zero Friction provides metering and billing software as a service together with an out-of-the-box customizable end-user portal that aims at providing insights to end users in their invoices and energy consumption. With our platform, we aim to lower the cost to serve for thermal suppliers of all sizes by focusing on exceptions and automating back-office processes where possible. Well, resources, and more specifically people, are very scarce in a startup. So by selecting Azure Cosmos DB as our main data storage, we aim to solve this as we didn't need to pay a lot of attention to scaling setup, indexing, backups, and all the typical DBA activities you would require, which would allow us to focus on where we bring the most value, our software. So together with the fact that Cosmos DB is a schema-less database, it also allowed us to evolve our schema naturally with our application. Since Cosmos DB is offered as a software as a service solution on its own, we didn't need to take care of any high availability during any updates of the underlying service of Cosmos DB. So as all the software and infrastructure related upgrades, they were done by Microsoft, complying with the SLA requirements associated with the service. Therefore, we could fully focus on achieving and maintaining the SLA of our platform by implementing rolling upgrades and failover nodes. And also, since we use autopilot, our platform scales throughput efficiently, but at least as important, cost efficient as well, which creates a USP of our platform, being a platform that is actually scalable for all sizes of thermal suppliers, going from the very small ones to with only a few hundred connections, to suppliers who have hundreds of thousands of connections and still being cost efficient.
Welcome back, and thank you so much, Yoni. Glad to hear that Cosmos DB is working out well at Zero Friction. I think what you said about the fact that resources are scarce in a startup, you really want to be focusing on your core use case, your application. You don't want to be there spending hours and hours tuning your database. So it's awesome to hear that Cosmos DB just worked. So many things it gives you out of the box. I think another thing you called out that will resonate with a lot of our customers is your usage of autoscale. right? The ability to not having to worry about, do I have enough throughput? Do I need more? Do I have like a sudden peak time? Just set the max RUs you want, set the peak you think you expect, and let Cosmos DB handle scaling up instantly when you need it, and scale back down instantly, even just as important to help you save cost when you're not actually using it. Tara, what do you think?
Yeah, it's really cool. I'm glad that they're using Cosmos DB with zero friction for zero friction. So really cool to see that our customers actually are using our services and like getting great solutions with them. I really enjoyed the talk with the Walgreens use case. I actually just picked up a prescription from Walgreens last week, and it's so cool to know that like the product that I'm working on is actually being used in my like day-to-day life, because if you want to, if it's as simple as like picking up your prescription, Cosmos DB is empowering other people to build solutions on top of that as well. So I think that's super cool, and like I'm learning so much. Even though I work here, I'm learning so much about the product, and I can't wait to like go back and view these talks and all the on-demand content that we have as well. So very excited for that, and just very excited to like hear from our customers and hear what they're saying as well. And again, if any of this resonates for you, come back next year and give a talk as well for Cosmos DB conference.
Yeah, definitely. You could really have a whole day where you just use things on Cosmos DB, pick up a prescription, use Microsoft Teams, file a healthcare claim, right? Talk to ChatGPT.
Yeah, I think
and so much more.
But I think Buffalo Wild Wings uses Cosmos DB as well. It's funny that like any little thing might be powered by this service. So it's really cool to see the scale that this product has grown to.
Yeah. All right, let's take a look at socials and give out some more shout outs. So first off, we have Peter, who said of the previous talks from Stephanie, this is a great walkthrough of log analytics. Yeah, definitely the inbuilt log analytics examples in the workbooks, super helpful. We've also got Sarif, who says, hello from India. Nice to hear.
Yeah, I see a comment from Sumit. He says that he's enjoying this conference thoroughly. There's lots of great innovations on the way, and he's learning real use cases. So if you're someone who's new to Cosmos DB and thinking of trying this out, we hope that like all of these sessions will definitely make that decision easier for you as well.
Yeah. We have a free tier too, so you can just try it for free. Let us know what you think.
Give it a shot. You don't have to pay for anything. Just see if this service works for you.
I think lastly we have someone saying hello from Mexico, and then Peter again said great mix of different use cases, utilization of different APIs and SDKs. Yeah, Cosmos DB, there's not just NoSQL DB, we've also got a huge Postgres for Cosmos DB as well. So I think earlier we also showed a teaser for CitusConf, which is coming up later in April. So if you like this conference, you should definitely check out CitusConf as well.
Yeah, definitely. Cool. So next up, we have Mark Heckler of our cloud advocacy team to talk about planetary scale database bliss.
Sounds good. And after that, we'll have community member Noah Stahl, who will tell us about his adventures in building SaaS applications with Cosmos DB.
Again, don't forget to comment and send us questions on YouTube, or feel free to tweet with the hashtag Azure Cosmos DB Conference. We have it on our laptops, and we're ready to give some shout outs and just learn more about how you're enjoying this conference.
Hi, welcome to this session on taming your data monsters with Spring Boot and Azure Cosmos DB for planetary scale database bliss. My name is Mark Heckler. I'm a principal cloud advocate of Java and JVM languages with Microsoft. Our time together today is very short, so if you have any questions, comments, or feedback, please do reach out to me via email, or better yet, via Twitter or Mastodon at mkheck. So a bit about me. I am an architect and developer by trade. I am also obviously a principal cloud advocate here at Microsoft. I solo authored a book called Spring Boot Up and Running, Building Cloud Native Java and Kotlin Applications. So you might gather from that, I am a Java champion and a Kotlin developer expert. And just for fun, I'm also an instrument-rated licensed pilot, because everyone needs a hobby, right? So what's on the agenda today? First, we're going to discuss Spring Boot for enterprise Java development. Then we're going to talk about database options supported by Spring, and there are many. So it's very nice to know that you have good options, and that in many ways, it's good to help refine those options to make better choices. We'll start with a demo when we get into the demoing using a local development database, because although there are various permutations as developers, most of the time we work locally in some fashion or another. And then from there, we'll go to a demo with Azure Cosmos DB and see how easy it is to scale from dev to prod. We will then summarize with just some links and some more information and what have you. So first, Spring Boot really does dominate the enterprise Java space. The Java ecosystem is absolutely huge. And Spring Boot, the smallest number I've seen is that over 57% of all Java developers use Spring Boot. And depending on who you listen to, that may be significantly higher. Why? I guess that's the first question. If you're not already using Spring Boot, you may be questioning, why am I not? Well, Spring Boot has a very developer-first focus. When you're new to Java development, or any development for that matter, there are many cases that you run into that there are a lot of steps that are involved to do a particular task. And the first time you do that, it seems very onerous because you're new, right? And you're learning to do this. So there seems like there are a million steps to do one thing. After you do that 2 or 5 or 10 times, you start to realize that, wow, this really is kind of, this is a lot, right? And it seems like there are a lot of steps here that I'm doing that are repeating themselves with 0 or very few changes between different times you're doing the same task. After you do that 50 or 100 times, you kind of become numb to it. And then it just seems like that's the way it has to be. But the Spring Boot developers took a different tack. They looked at patterns that formed. And when you see the same thing happening over and over again with little or no variation, that's easily isolated into a pattern. And that's where things like auto configuration come into play, because it makes your life as a developer easier. It bends the framework around you versus you having to bend around a particular framework. So auto configuration is one example of that. And auto configuration is employed by Spring Boot applications at build time and at runtime to evaluate what you have in your application. So whether it's dependencies on your class path or your code or annotations or properties you set or beans you create in your application, all of these things are taken into account by the application either, again, at build time or startup, so that sensible defaults take place and sensible conditions are met, either positively or negatively. One example is that if you have a database driver on your class path and you define a data repository in your code, it kind of follows that your application should connect to a data store, right? And this seems very obvious. And of course, each time you connect to a database of some kind, you'll need to open that connection. And then when you're done, before your application closes, you'll want to close that connection. So why do we do this as developers? Why do we do this manually? Your framework should support that. If each time you connect to a database, it has to make a connection and then close the connection around everything else that you need to do, why doesn't it handle it for you? And of course, Spring Boot does. So things like that roll all together to make auto configuration work for you. There's also simplified dependency management. So in typical Java fashion in the past, and even in some circumstances in today's climate, you will have a long list of dependencies that you'll have to incorporate to do a particular, maybe it's a very complex task, but it's still a task. And Spring Boot elevates the focus from dependencies to capabilities. So for instance, if you're developing an application that you need to use to expose a web-based API, you'll want to listen on a particular port, for instance, and take requests, accept requests, process them in some way, and provide responses. And all of those things work together. So by elevating the focus to a capability, all of the libraries that are necessary to perform those tasks as one unit are brought in and version synchronized and tested together. You can override those, you can change those out, but 99.99% of the time you don't need to, and therefore you just know it works. Simplified deployment is another feature of Spring Boot, because out of the box, you have the ability to deploy things as an executable jar, for instance, to the Java virtual machine environments. You also have the ability to create native images, native code, container images, and all of that is baked in and very simply done. So it simplifies your process of getting to production. Standards are supported, so long-standing Java standards, as well as those that are coming onto the scene currently and will be, as well as gaps in perhaps things that are addressed by the Java specifications, but are frequently used and demanded by Java developers. So Spring Boot kind of covers all of that, and I like to think works hard for you. Spring Data works similarly, and as I like to say, it works with everything. And there's probably something out there that if you come up with a new database today, maybe you don't yet have drivers for it, But chances are, if it's a relational database, within a couple days or a couple weeks, you're going to have JDBC, Java Database Connectivity Drivers. You're going to support JPA, the Java Persistence API. If you have a NoSQL database, you're going to want that to work with Java, among other top-tier programming languages. Spring Data has support for that. Again, out of the box, several different NoSQL databases of different kinds. So everything from graph databases, key value, wide table, document-based, in-memory, persistent. It's just in there. And of course, the ability to add more comes quite easily as well. There are different layers of abstraction. So whether you want to work directly with the data store, or more likely a template-based API, or even a repository-based API, which provides a very clean abstraction for most of the things that we do as developers on a daily basis. Blocking, non-blocking reactive APIs are provided as well. So it, again, like most things, it just works. So a bit of demo now, because I like to kind of show things in action. Before I show the action, though, I want to show the setup, because this is a very intentionally streamlined application that I've created in Spring Boot to work with, in this case, MongoDB locally and Azure Cosmos DB for MongoDB in the cloud. Now, I also have another example out there using Azure Cosmos DB for Postgres. There are many others. I have another one that I haven't actually committed to GitHub yet, but will shortly. And what I want to do is build out a portfolio that shows just how dead simple it is to develop robust, production-ready Spring Boot applications using Java that you can develop and iterate through and refine locally and push to production and scale globally. So a quick look at this. Again, this is intentionally very, very simple. I just added a couple of dependencies here. So I have the Spring Boot starter for MongoDB. I have the Spring Boot starter for web that allows me to build web-based APIs. And then if I look at our application properties, this is where your sensible defaults come in. And if you define certain properties, you can override those defaults that Spring Boot and Spring Data and all the other Spring projects take for granted. So for instance, a data source URL, I'm not providing that here because I want the defaults of running and checking for a local database running on the default port, in this case, MongoDB, so 27017 if memory serves. It will look for that locally and find it and use that. If you want to override that, it's as simple as providing that that value for a property here, or in other ways that your Spring Boot application will pull the environment and pull that in. I like to use environment variables, and I'll show you that in a moment as well. So a quick tour of this. This is our domain class, our person record. I'm using Java records here for our MongoDB-based example. And again, very simple. It's just the database ID, first name, last name, and address. And of course, in other genres, like with Postgres, I'm actually using Java classes, and I think I use Lombok with that. I have another example where I'm not using Lombok, and I'm just using the standard getters, setters that we create ourselves as developers many times. But you have options. As a developer, you have options. I'm defining a public interface here, a person repository interface. And this is a great example of both Spring Data's capabilities that we're exposing. This is a CRUD repository, exposing the capabilities to do create, read, update, and delete operations for objects of type person with an ID of type string. And I'm extending that here, and Spring Boot's auto configuration sees that I have a MongoDB database driver on my class path. It sees that I'm actually extending a Spring Data repository interface, and it makes those connections and creates a proxy bean for us to interact with our data store underneath without any additional code on our part, which is huge. We can extend that. We can define certain query methods and things like that, and follow conventions that make that very simple to use, as well as using the native query language for whichever database we're using. But in this case, I'm, again, keeping it intentionally simple. I have a data loader class that just allows me to drop a couple of records in there. I clean up in case I have a run from before that I left data out there, add a couple of records, and then just return them in the log so I can see them. And then, of course, the controller is where I expose the web API. In this case, I just have a REST controller to return the objects in the form of JSON. I'm returning all persons and then searching for a person by ID, grabbing the first person that is returned from a query for find all, and then posting a new person. So again, very intentionally streamlined application. So let's take a look at how this works. I'm going to just do a Maven Spring Boot run and run this with no properties defined. And what should happen is the Spring Boot application will go and look for a local database to connect to. All right, so we're running this and we're getting the local MongoDB instance. I'm running this using Docker Desktop here on the Mac. But again, you can do this any number of ways. It's just looking for a local MongoDB instance exposed on the default port. And if I go to query this, just hit 8080 for the endpoint, then I can see that it's working. And I'm getting back the 2 records that I know are out there. So that's kind of a quick and easy test of that. Now, if I want to connect to Azure Cosmos DB for MongoDB, what I want to do is just show, let's take a look here. And you see that I've defined an environment variable here, Spring Data MongoDB URI. And Spring Boot also has environment variable and environment processing capabilities wired in. So if you define this in your properties, spring.data.mongodb.uri, it works just fine. But you also can override that externally at runtime. So here, it translates the underscores to dots. It brings this in as spring.data.mongodb.uri, processes this, knows that I want to point to a data store out here on Azure, which is Azure Cosmos DB for MongoDB, and it will connect to that instead with 0 effort on my part whatsoever, which is huge. Talk about making it super easy to go from dev to prod. And here we see exactly that the address is now pointing to a cloud-based instance of our database. And then if I go back and just check that again, there we go. So that's super simple, right? We went from dev to prod with absolutely no headaches on our part. But what happens when it's time to scale? And that's where it really, really gets exciting. So I have the data store shown here, my Azure Cosmos DB for MongoDB. And I've already done a little bit of configuration on this because instead of just pointing to a single location, I have East US set for the right location, and I have East US and West US set for our read locations already. Now, that's just the start, as I mentioned. You can actually go here to replicate data globally, and you can see that we can set up various different write regions, read regions. We can set up availability zones. So even if within a region you have a failure, it seamlessly converts over and reconnects everyone to that the other location within that availability zone. You can enable multi-region writes so that you can have folks, if you have user communities here in Brazil and here in South Africa and here in Australia, and here in the US and Europe, you can have write capabilities as well as read capabilities, obviously, around the globe and the writes are automatically synchronized among them. So it takes the headaches out of that for you as well. You get global scale in a blissful way because the database does the work on your behalf. So we're almost out of time. I want to come back and just wrap up with a couple of things. Spring Boot gives developers superpowers, and I think you've seen a hint of that today. Very developer-first focus in terms of the application and database support. But Azure Cosmos DB takes your data from dev to prod, and it scales it out around the globe. It's super easy to implement. It's super easy to manage. If you want to know more, here's the URL for the meta repo. I'll be adding that sub-repos to that as well. It's got a couple out there already. And if you want to know more about Azure Cosmos DB, because who doesn't, check out the links at the bottom. With that, I will leave you. Happy coding and have a great conference.
Hey, welcome to the Azure Cosmos DB conference. I am going to be talking about building a SaaS product with Azure Cosmos DB, and in particular, focusing on how not to overcomplicate things when doing that. I'm Noah. I built Skyplug, and that's what we're going to be talking about today. So I want to make a first assumption or assertion, which is dependencies are liabilities. And what I mean by that is that when we take dependencies on libraries or on services that are outside of our application or system, we're actually increasing the surface area of pain that we might experience. So if it's a library, we have to understand how it works. We have to configure it correctly. We have to make sure when we upgrade it that we're never breaking something or that we're never introducing a security vulnerability. If it's a service, of course, it can go down, it can have an outage, it can stop working, it can add performance overhead. And at the very least, even if things do work well, we have to understand how these things work, and we have to read documentation. And so really what I'm trying to say is the more dependencies you have, the more bad things can happen. On the contrary, I want to say that simplicity is winning. And what I mean by that is the simpler we can make things, the better for our users and for ourselves. And that requires, I think, mostly getting rid of dependencies or avoiding them. So with that in mind, let's do a little case study, and I'm going to use Skyplug as an example here. So what is Skyplug? It's actually just a SaaS application. It's pretty straightforward. It automates your virtual machines in Azure to turn on and turn off, and you do that on a schedule. So imagine that at 7 a.m. on Monday morning, you want to start up some VMs, maybe it's a terminal server, a build server, whatever, and then at 6 p.m., you're going to turn that back off again. And on the weekends, we're just going to keep them off altogether. Users use that to save a bunch of money on their VM costs. Pretty straightforward proposition, pretty straightforward goal. And the other two goals are just that it just works. It does exactly what I just said. It only does that, and it does it well. And that, very importantly, and what I'll focus on a lot here, is that it always works. It's super reliable, 100% uptime. Every minute of every day of every week, all year long, it's just going to do that scheduling and run those jobs. So with those goals in mind, let's think about, like, how would we build this thing? Here's kind of a first draft, or at least how I started thinking about it originally. And this is more or less typical boilerplate kind of architecture. So of course, we know we need a CDN. Every web app needs a CDN. We put our web assets in blob storage and store those along with other assets that we might need that are static and file in nature. We have SignalR up here to do some fancy real-time streaming of updates so the client can always be in sync. We have a bunch of web applications as microservices here behind Traffic Manager, which I'll talk about all this later. We have Azure Functions running in the background. We gravitate towards that because we have seen many tutorials that Azure has put out around how to use functions. A lot of times it's with a change feed, and you read from Cosmos DB. You're using a timer function, perhaps, like every minute we would read the database and find out what is our job to run right now. We're going to put that into a queue. That queue is going to feed another function that actually runs the job, and so on. And most importantly, or relevant to the previous point I was just making about reliability, as you know, when we go and select where we want our blob storage or our queue, we have to pick a region. So implicitly, all of this resides in the same region. And that is something that I would say is a problem. So to tell a quick story, in 2018, the original version of Skyplug was actually all hosted in one region that happened to be the Southeast US. And if you were back around in those days, you remember that there was a lightning strike that hit Azure right at the data center and took the whole thing offline for at least 4 days. So basically during that time, all I was able to do was wait for Azure to come back online, repair whatever the lightning did, and just be embarrassed the whole time. So lesson learned from that, you should not put everything in a single region. So this brings us to what I consider to be the baseline pattern going forward, at least for me, which is we need to have multiple regions at the beginning by default and just fundamentally. So in this picture, you can see we have a West US version of Skyplug and East US version of Skyplug. Those are actually self-contained, completely isolated, and they can all, or rather everything inside of this is the full architecture. It can do everything that the system does. And then we just go to it as a user based on a requested traffic manager to say, hey, I want to go to the nearest alive data center and transact with that thing. So this is a fully redundant shared nothing architecture, and it's made possible by Cosmos DB having its geographically separated replication, and that happening transparently in a turnkey fashion. We can really build this out pretty simply with just turning that on and that at the core. So I would suggest that doing that at the beginning, making that decision and having that constraint, that it allowed a lot of simplifications to happen. Let me just go through what some of those were. So remember, I mentioned a CDN up here. The CDN is really something that allows us to distribute content across different regions. But if you remember this picture, we're already doing that to an extent. I could have more regions anywhere I wanted to get content to. So what I opted to do is just remove the CDN altogether and use a static web instance inside of each region as basically what the CDN was supposed to do in the first place. So CDN goes away. We just have regional web instances. One dependency removed. How about Signal R? Well, with Signal R, you have another question there about complexity. There's a two-way communication happening. There is state that has to be maintained. And there is a problem with testing. You never know when data is flowing in which direction. So again, having worked with Signal R quite a bit over time, I found that it was causing more pain sometimes than it was worth. So I just dropped back to simple polling. And you might think, well, polling, that's like the caveman strategy. But honestly, this is about keeping things simple and like removing things, removing fanciness, removing features. So Signal R is gone from the picture. What about Azure Functions? So Azure Functions is just what we see in all the tutorials, and it seems like Azure Functions and Cosmos DB somehow go together. They don't need to be, and you can just use ASP.NET Core and worker services to do all the background processing. That's certainly what I would recommend doing, and I would just steer clear of Azure Functions altogether. It's really just a huge bundle of dependencies, going back to what I was saying earlier. So Azure Functions, gone. What about blob storage? Another thing that we always put in our app architecture right away. We need blob storage, right? Well, Skyplug doesn't use blob storage at all. I was on this path, we're going down this list, and I thought, can I get rid of blob storage? Is that really possible? And indeed it is, at least in my case. So I just use, for all of the things that needed to know, or rather needed to store something in blob storage, I found a way to get them into Cosmos instead. So that included data protection keys, it included certificates, and some other data, nothing heavy, so stuff that would actually fit within a document in Cosmos. So no blob storage, that's gone. How about queues? If you remember my picture before, we need queues to like send jobs out, collect jobs back in where the workers are going to run them. Again, those things are single region, those things can fail. We don't want to have any single point of failure. So again, I figured, can I get rid of queues? This is actually the most interesting part of this whole project, and I'm sad that I can't show you how this actually was implemented. It's kind of fun, but we use a Cosmos container and treat that as a queue and implement some custom code around it just to do the minimal queue semantics. And what we have in the end is a fully distributed, reliable queue system that allows the Skyplug to do like a consensus around who is going to run schedules at every given minute of the day. So no queues anymore. And then the change feed, this is a little bit, this is just like once you're on this path, you think, how many things can I remove? Change feed was one of these where I thought, well, I've always been a proponent of the change feed in the past, but is it really necessary? And I thought about it, and I couldn't come up with a reason why it was necessary in my case, over and above just a simple polling loop. And so I removed the change feed as well. So that got all of these dependencies, all of these SDK references, everything associated with all of this stuff just disappeared from the system as a consequence of doing that. And so here's what we end up with kind of architecturally. All the stuff you remember around the edges is gone. This is all cleaned up. Azure Functions is replaced by ASP.NET Core services. We still have these microservice things in the middle, and traffic managers feeding everyone to a given region. But if you think about what this represents, really, it's just Cosmos DB, it's Azure App Services, and it is Traffic Manager. That's basically all that is used to run the system. And so it actually ended up being super simple and very easy to maintain. So summary of what I just covered and just a few closing comments, I guess. A fundamental constraint can simplify things. The fundamental constraint that I was referring to is taking the view that you need to have geo-distribution and shared nothing architecture in your system, pretty much no matter what you're doing. And if you do that, you think it would be immediately more complex to achieve that. But in this case, I found it actually forced me to think about things in a more simple way. So it ended up being a win rather than a cost. Again, fewer dependencies mean fewer liabilities. Skyplug is very easy to maintain. It has very few dependencies and libraries in it. And it's just like when it runs perfectly 24 hours a day and with no issues. So there's very little to go wrong and variables in that regard. The other thing, simplicity is something that's good though that requires effort. So we can't get it just by default. I think the assumption I used to make was, well, you start with an empty project. It's simple right away, right? But the process is always, you're going to end up with complexity and you're not going to have a simple result unless you really try, because it's too tempting to add in every new service, every new shiny thing that we come across that would seem cool to add into our system. So you got to resist that. And I guess finally, it's just, for us at this conference, it's the fact that Azure Cosmos DB is uniquely suited to enable this architecture, I think is really the cool killer feature here, that at least that I was able to take advantage of to make this app really easy to develop. So with that, I thank you for watching. If you want to reach out, if you have any questions about what I covered, curiosities, or just want to criticize this idea or something, you can do that. My email is right here, and then the website for the app, if you want to check out what that looks like, is down here. So hopefully that was helpful. Hopefully you learned something, and I hope you have a good rest of the conference. Thanks.
Wow, that was such a great talk. And I can't believe we only have one more talk left in this conference. Time is just flying because we're having so much fun. And remember, you can check out any of the resources that we've mentioned in these talks at aka.ms/Azure Cosmos DB Conf /collection. And yeah, it was great to see how Skyplug really simplified their overall architecture using Azure Cosmos DB. And like he mentioned, simple is good and it requires effort, but would you rather have a lot of effort in the beginning and then have your overall architecture be simple, or low effort in the beginning and have a complex architecture? I would much prefer the prior. So thank you, Noah, so much for explaining all of that to us as well. And again, highlighting the point he said that Azure Cosmos DB really enables the shared nothing reliable architecture. And I think that's just a really good win-win for our vendors as well as our service as well. So Deborah, did you want to touch on anything he talked about as well?
Yeah, definitely. I mean, how many people and developers can say, oh yeah, the code base I work on, the product I build is easy to maintain? What a dream, right? Yeah. So the idea that you can have one component like Cosmos DB do a lot of the heavy lifting of being your data store, but also being working as a queue in some contexts is really great to see the variety of use cases. Another thing that Noah talked about that stuck out to me, which I think all of our customers should also always think about, is if you're running a service that needs to be highly available, and everything is pretty much needs to be always on, all on demand, always available all the time now. Cosmos DB makes it super easy to just get HA by adding a second region. You can literally go to the portal, click the region you want, and after, depending on how much data you have, after 30 minutes or so, depending for smaller, depending on how much data, it could be longer if you have terabytes and terabytes. But you can get a second region. Cosmos DB does it for you automatically. You can go from 4 nines of availability to 5 nines. 5 nines, by the way, is 5.26. I looked this up before. 5.26 minutes of less than that per year. That's the most you could ever have. In practice, Cosmos DB runs much higher HA than that. So it's awesome to see, customers like Skyplug and Noah taking advantage of it. We have a lot of other customers who have sometimes multiple regions. In addition to HA, you also want to be close to your customers, right? If most of your customers are on this continent, it makes sense to have your application and your database in that region as well.
Yeah, I totally agree there. It was really nice hearing about that capacity and how they've used it for their users. I guess like we've had so many talks so far. I can't believe we just have one more left. But I guess what was your favorite talk of this conference so far?
Oh my gosh, I don't know. Putting me on the spot here. I guess maybe not so much a single talk, it's hard to pick favorites, but just a theme, the variety of hearing all these best practices, right? Hearing how you can optimize your workloads, optimize your queries, how you can actually use change feed, which we sometimes call the unsung hero of Cosmos DB. I think of a talk like that on YouTube. Just hearing not just Cosmos DB, but how Cosmos DB is working well with the rest of the Azure ecosystem, like Logic Apps, AI services, Traffic Manager, and more to really build a full solution end to end.
Yeah, I definitely agree. I definitely really liked the talk that, or I guess like the keynote that Kirill gave was crazy good. I didn't know that OpenAI was using Cosmos DB, but that just proves to point that we have so much of availability on our service, and I'm really excited to see that going as well. Yeah. You want to introduce the next talk?
Let's do it. This is the last and final talk. We've got Chandra Dal, the CEO of Kasdan, who will talk about something that is really relevant to all developers using Cosmos DB, which is real-world data modeling and performance.
Awesome.
Hello, everyone. I'm Chandra Dal, CEO of Kasdan. I'm very grateful to have some of the awards that are listed here, especially Microsoft MVP for 12 years. I've written a book on scalability patterns. If you have any questions about this presentation, please feel free to reach out to my team, kasdan@kasdan.com. So let's get started. The first thing I would like to point out is a beautiful presentation by my friend Mark Brown, Principal Program Manager at Azure Cosmos DB team Microsoft, and his talk on data modeling and partitioning. I cannot do justice to data modeling and partitioning in 15 minutes, so I only have 3 really good patterns for you. But if you have not watched this talk, I highly recommend it. It's on YouTube, and feel free to check out the GitHub repo listed down there. Here's my LinkedIn. Please feel free to add me. At Kasdan, we use 30+ data modeling patterns, and Kasdan's a preferred Microsoft partner on Microsoft Azure Cosmos DB. We work with Fortune 500 clients, large size, mid-size, small companies, as well as startups all over the world. So we have this amazing benefit that we pretty much work on a lot of use cases. And let's be clear, 3 patterns are enough to show and demonstrate the power of patterns and how this could be really good, not just in terms of reducing your request charge. It also can speed up your queries, makes your life so much easier as a developer, and down the line have so many exponential benefits for your company. Now, I will not be discussing anything that Azure Cosmos DB optimizes on its own. That may include, indexing or caching or anything that's with the framework. This talk is specifically to show you 3 different data modeling patterns and how their combination leads to great results. And one more thing, patterns are problem specific and use case specific. So what we cannot do is take the same pattern and solve all problems out there. Now that's principles. And even though we may have great principles that can solve most problems, let's say for object-oriented, that is not necessarily true for a pattern. Pattern is always problem and use case specific. So why is data modeling important? One of the best things about the presentation today is I'm going to show you how, by using the right data modeling patterns, we can reduce the total request time by 75%. So it's an improvement of 75%. We have been able to do this multiple times, but I'm going to show you examples where request charge is going to be improved by 99%, and so is your query time. And by the way, output document size. Now this is a hard one. How do you improve anything by 100%? Well, it's actually 99.98%, which is pretty close to 100%. This is exciting. Let's get started and see how we code in the industry. Happy beginning, right? Everyone says, oh, by the way, we got a product to launch. It's right there on the right-hand side. And there's a name, here's a brand, and here's a price, and maybe a bunch of colors. Done. And what do we come up with? We come up with a flat document on the left-hand side. As you can see, we have a bunch of properties over there, and then we have reviews. And life is simple. Not exactly. Now, just so you know, all the data is generated by bogus NuGet package, 40 million downloads. It's great. However, it's not real data. It looks like real data. It's great for demos. So after some time, we actually start seeing the real problems. Oh, wait a minute. 8,371 comments. Whoa. And then look at the right-hand side. We never thought about, oh, wait, how many actual comments there would be. And if there are those comments and there are multiple stars, we got to do the math on finding out the average of all the 5 stars, right? And those are the problems we start seeing in real life once we start getting into production. We have new features coming in every month, every year, and that's what the life of a software developer is, isn't it? Next, the client comes to us and says, we need to add ratings and reviews because a competitor has it. And we're like, yeah, why? Not a big problem, right? Except that's how it looks now. And you can notice the amount of math it would take to make this happen. So we need 5 stars, and there's 7,000 reviews that are 5 stars. So someone's got to do the math. And then we have 4-star reviews, another 575 reviews, and there's 3 more other categories. So let's look at the data model. So let's give you an example of how it will look in real life, and just pick 1 or 2 of these. And you notice that there's simply name, description, price, brand, category, and a bunch of reviews. It's all good, right? Now, what we always do when we actually code is do something like, okay, I'm going to create something called products 200. Now, you don't want to do this in production, but when you're testing something, it's a good idea to test something with 200 records and then test the same exact entity. There's really no difference whatsoever with 10,000 records and see what happens. And once in a while, what we also do is also look for something like, for example, reviews, right? We had 8,000 reviews in that particular case. So how about having an actual product with something like that, which is, let's look at the array length and it'll tell you how many reviews we have. We have 5,000 reviews here. So we want to test this before we get into production. And then, of course, we want to optimize this, and anything optimized with 10,000 records is going to be in products optimized container. That's it. So let's show you the products as in very simple document with the same exact data structure we showed you earlier, which is a flat document with a bunch of reviews. Now, a lot of you are probably thinking, well, reviews probably don't belong in here, especially if there are going to be thousands of reviews. So what do? You say, well, embed versus reference, and reference might be a good idea. That's true. Now, for the sake of simplicity, we're going to keep everything embedded. And just so you know, for this particular use case, embedding actually works better, even though it's not 1:few. And again, patterns are problem specific. So in this case, it works for us, and we've done the math on it. We've seen the document size, every single thing for thousands of reviews, and it works great. So now, how do we optimize this? Let's look at that. So the first thing would be optimizing in a way that this record is available to us. Now, wait. The clients always say this. We want everything really fast, right? So no loading GIF, please. You don't want to have that. Okay, so that's a big challenge. So what do? We have 2 options. One is we keep the product as it is and then write an optimization, or we change the data structure to something like this. Now, there's 2 patterns going on here. Average rating and total ratings are pre-compute patterns. What does that mean? Anytime we add a record, we make sure we calculate the average rating as well as total ratings and get done. And then there's a second pattern going on over here, which is ratings underscore facets. And what are facets? Facets are a way to categorize your data in a way that you can later use it. So here's a dictionary, which literally aggregates your data in a category of facets. In this case, the category is rating. You could have had a different category called brand. Let's say you've got Nike, you've got Puma, you've got Adidas, and that's another category. That's another facet. You could also have had another facet with sizes, XL, large, medium, small, and other sizes whatsoever. And this is why it makes sense not to flatten it out, but to keep it in a dictionary. In this case, it's rating facets. So we've got 2 optimizations going on with the pre-compute pattern as well as the facet pattern. All right, so let's look at the results. Wow. So just so you know, these are not Cosmos DB query times. They're going to be a lot lower than this. These are actually the time for the full request. So request time for the entire request. 52% improvement just by using 2 optimizations on request time. What about the request charge? Oh, wow, your bill just got lowered by almost 64% because the request charge is only 5.78 versus 15.98. And these are ratings for a single product. Wait a minute, the output document size, oh my gosh, I said 100%. Well, we're pretty close, 99.98%. And keep in mind, that's kilobytes, and that's just a byte. That's huge. If you could reduce the document size, that in itself is a huge advantage for your scalability. Why is that? Imagine you've got app service on Azure and you're making a bunch of these kind of requests. What if these are thousands or millions of these requests? You will reduce your scalability if your document size is higher. So it's important to keep that lower, because now you need less app services to serve the same amount of requests. All right, so the only major difference on the right-hand side is pre-computation and faceting, and we covered 2 patterns, and the results are right in front of your eyes. And just so you know, you could do something like this and make a call pretty quickly from Postman, as we can see here, the elapsed time. And this will change, by the way. It will change for the actual product that we have. But these metrics are extremely important, and these are part of Cosmos DB. And I highly recommend looking at all these metrics, especially when you're doing product optimization. And in this case, we can make the same exact thing happen. And you will notice there's a different elapsed time, but look at the request charge is 5.78. In this case, the request charge was 15.98, and the other differences. So let's see what all we have after this preferred solution, which, as mentioned earlier, all we got to do is add these 3 properties in the document, which is product. Now, when you do optimize this, right, you actually have a second version of product. So please keep in mind, you may have to keep versioning in mind, because you may have older documents that may not have had that product. So until every single data piece, as in document, moves to the latest version, you will have to support the 2 versions. That's a very normal optimization we do all the time. We just wanted to make sure that that is not ignored. And then let's talk about, what if you want ratings for entire products? Now, this is important to understand, that even though the preferred optimization is better in this case by almost 50%, this is a very edge use case. You're not going to call your entire database all the time to get all ratings, but we wanted to compare this in front of you, and the results are pretty amazing. 50% request charge. Now keep in mind, this is all products, 10,000 products. Request unit is 320, still 20% better than 415. Now, anytime we see something like this, we actually optimize it. So please remember, we're not going to pay RU of 330. We're going to have an optimization that I'll show you in a second that will be better than this one too. Moving forward, output document size. Again, we're talking megabytes versus kilobytes, 90% improvement. So optimization works really well for this particular scenario too. Now, product metadata pattern. And in this case, what we're going to do is the third pattern, which is aggregations. And once we do that, you will see a tremendous improvement in how we're making this work. So let's look at the results. First, we're going to compare the products 10K and products optimized. 26% improvement for getting all the rating facets that I just showed you. Wait a minute, 75% improvement when we add the aggregation pattern. So this is the third pattern which we're using on top of the 2. Now you notice the combination of patterns makes your performance so much better, makes your life so much easier as a developer. And of course, great for your business because you're spending a lot less money now. Request charge, oh my gosh, 99.45% improvement. I mean, we're going from 415 RU to 2.26 RU. I mean, definitely a pattern I highly recommend. And then finally, whoa, we're going from megabytes to kilobytes to now bytes. It's only 152 bytes output document size. And by the way, this is your Cosmos query time. Request time meant the entire round trip time. This is specifically Cosmos query time. And you can see we go from 81 seconds to just 0.23 seconds, 99.71% improvement. So how do we do the magic? Let's look at it. So what's product metadata? Products metadata is just one record. That's it. And what does it do? It creates aggregations. And remember, I gave you examples earlier, and we talked about rating facets. But what if we had brands? What if we had sizes and a bunch of different, product metadata facets or aggregates that we can aggregate all the facets in something like this. So we have facets, but we're aggregating all those facets in one document, literally one document. And this is the pattern, which is the aggregate pattern. I'll show you another example of this. Let's say something like brand, and we can show you what that looks like. Now, these are the results, and they're pretty phenomenal. And you can compare one by one, product and product optimized, and product metadata, product and product metadata. But oh my gosh, look at the last 3. more than 99%, all the way to 100% improvement. And the least one is still 75% better. Phenomenal results. Let's move on. Finally, when we have something like a brand, a lot of times users want to come on a website and say, only show me the brand I love, your favorite brand, and they click on that brand and ask you for the data for that particular brand. Now you'll notice these two look so similar that you go, wait a minute, it almost looks like an array. So what am I missing? And what is the difference if I do it in a different way? So we'll show you brand pattern, which is, the brand aggregate pattern, and we'll show you the brand, which is the normal brand, which is literally an array of brands, right? And we see the difference. So let's look at the difference. Well, request unit goes from 81 to 10.71. And your request time goes from 21 seconds to only 1.35 seconds. And finally, your documents, wait a minute, 2,400 documents for that particular product, and it's now just one document. You may not even believe me, right? So let's actually see if that is really the case. So let's make a call real quick. It's going to take some time, and this one's going to be extremely fast. And let's see what it is. All the way down. And by the way, retrieve document is 1, request charge is 10.71. We've got this one back, and as you can see, request charge is 81, and the documents are 2416. So how do we do this? Show you real quick. This is brands, and as you can see, there's a bunch of Adidas here, as you can see, and eventually you'll have Nike, Puma, and others, and they're all different records, and they have partitioning key, everything going on, as we always do, except in the metadata pattern, all you have is 4 different categories. So this is your aggregation pattern. In here, you're aggregating by the category. In this case, you only have 1 document for entire Adidas, 1 for Nike, 1 for Puma. And again, the size is so small, it's just 1 document. It's phenomenal. Let's have a look at the results. I mean, you can take, now we have actually a couple of extra things here. Retrieve document count is extremely important for us here because there is no reason to retrieve all the documents. Imagine having to get all the products for a particular brand. I mean, what if you have 200,000 of those? I mean, that's a lot. So we're only getting 1 back, and that's a 99% improvement. At the same time, query time is a 93% improvement. And as you can see, request charge is an 86% improvement. So this was our third pattern, which is an aggregate. And by the way, you could do this individually for your data and go on with it and get exponential benefits. So thank you so much for your time today. If you want us to help you with your Azure projects or big data AI projects or Cosmos DB projects, feel free to email Kasten and kasten.com. Thank you so much for your time today. Have a great day.
Hi, I'm Emily Sizek, and I am the CEO of The Postage. We are a private family network that helps families organize all their documents, build wills, and puts together all of their important messages and memories. With Azure's Cosmos DB, we've been able to efficiently build our business. When we started, I knew that I wanted to be capital efficient. I knew that I needed a team that was going to be able to scale, and what they've really been able to do is keep our team lean. We've only raised 1.5 million to date. And so I went to my CTO and said, hey, we need something that's efficient, that's effective, that also enables us to grow and scale quickly. And with transitions, when you never know how you're going to pivot and those sorts of pieces in your business, to be able to do that really easily as we brought on financial institutions, as we brought on insurance companies and those bigger businesses, they were able to trust our business and we were able to stay lean, which was really important. Azure Cosmos DB has enabled us to have trust with our future and current customers. Given the nature of our business, we need that to be so critical and so important. And because we have Azure and all the features that we've been able to unleash from our platform, we are able to have that trust, whether it's a financial institution, it's an insurance company, or if it's somebody like you at home that's filling out their information and planning for the future. We have the reliability and data governance of a big enterprise business, but we're able to move really quickly and deliver solutions for our customers that are unique, innovative, and different, with that reassurance that we are able to handle that and scale as their needs arise.
Welcome back to our last and final segment here. Thank you so much to our friends at the Postage for sharing their story with Cosmos DB with us, as well as it was great to hear from all those data modeling patterns from Kasten on really like how some small tweaks, small but thoughtful tweaks, can make a huge difference to your workload.
Yeah, it was really great to see him making those tweaks live and seeing the effect like right after it happened. He was doing a full walkthrough on like the Data Explorer and like how to check your RU charge, even run queries from the Data Explorer, which really is just awesome that we have this rich and powerful UI where users don't have to programmatically query if they want to. They can just do it directly from the UI. So I thought that was really cool, and it's so nice to see what those thoughtful actions are, and hopefully some of our users watching at home can test it out and tweak their workloads as well at home. So yeah, that was great. I think really just learned a lot. I can't believe we're already at the end of our session, and these 3 hours definitely like flew by super fast.
Yeah, I definitely learned something from the last data modeling talk. You know, we always talk about how in Cosmos DB, you really need to build your data model around your application and what the use cases are. And I thought that was such a great example of here's literally my UI, here's my website, here's all the use cases, like here's what I need to do for reviews, here's what I need to do for product, and literally optimize the data model to match that. And saved a lot of RUs and
money as well. Yeah, probably.
In the process. Yeah.
Yeah. Wow, this was really awesome. We do have some cool shout outs that we wanted to bring up. So we have a cat watching at home right now. I'm sure the cat is enjoying learning how to optimize their database model. Yeah, it's right there on the screen. So cute. Love that. So glad we have our little hybrid model where users, even furry little creatures, can learn about data modeling now. Yeah. So that's awesome.
Yeah. And if you liked watching this, you know, today was just a 3-hour long show, but we actually run a Cosmos DB YouTube channel year-round hosted by Mark Brown. I think Tara, you and I have both been on it, as well as many of the folks you've seen today and other members of the broader Cosmos DB team. Check out Cosmos DB Live TV. That's aka.ms/Azure Cosmos DB Live TV. We have, there's 2 exciting videos or 2 exciting episodes coming up soon on the data API builder and another one about benchmarking and how Cosmos DB compares to other types of solutions. Really great presentations there. If you miss any of these sessions or want to watch it again or catch every detail, check out the on-demands. They're all available on YouTube for, I guess, perpetuity future. So please check those out as well. And finally, if you liked Cosmos DB Conf, check out our sibling conference, Citus Conf. This will be all about Postgres. And then if you want more Postgres, check out the on-demand talks by Adam and Sai on Cosmos DB for Postgres in the Cosmos DB Conf on-demand collection.
Of course, feel free to subscribe to our social media channels to stay up to date on all the latest news about Cosmos DB and our future releases and conferences. In a couple months, we'll have the Build conference, so make sure you're staying up to date with our Twitter accounts and YouTube accounts to get all the information you need to make your life easier when using Cosmos DB. Additionally, there was a lot of hype around the new MongoDB vCore offering. So if you missed that session, definitely go to the on-demand session and watch Gal talk about that release. And you can also find his new blog post on our website as well, where he talks about that and all the cool new things you can start to play with. We'd once again like to give a special thanks to all our speakers. We heard from a long list of them: Kirill, Gal, Justine, Brian, Stephanie, Daniel, Yoni, Alex, Raj, Mark, Noah, and last but definitely not the least, Chandra today.
And our friends at the Postage.
Yeah, and our friends at the Postage as well. So thank you to these speakers for sharing your knowledge and spending time with us today. A very special thank you to the production crew here at Microsoft as well for making things run so smoothly and having us here as well. Like, it was such an enjoyable experience.
Yeah, so much work really goes into producing this event. So again, just want to reiterate, thank you to everyone. Thank you to our production crew and all the speakers who spent the time to really work on their talks, to think about what would be most relevant to the Cosmos DB community and be able to share that with you. You today. It was a huge team effort to build any product, including Cosmos DB. So Tara and I are super honored to be able to help host the show and show off the amazing work that the team and community and customers have done with Cosmos DB.
Yeah, and thank you guys all for tuning in. Thank you to our community as well for having such an engaging community and like being kept up to date on everything Cosmos DB related as well. So we can't wait to see you again next year. And until then, keep reaching for the stars with your apps powered by Azure Cosmos DB. Goodbye.
Thank you for joining Azure Cosmos DB Conf 2023. We'll see you next year.
We'll see you next year.
Thank you for joining us for Azure Cosmos DB Conf 2023. We'll see you next year.
Thank you.
Thank you.
Thank you.
Thank you.
Thank you.
Thank you.
Thank you for joining.
We'll see you next year.